I made a shocking discovery today when I was hanging out over at MEUK's Discord server.
Are we gonna keep on fighting? Are we gonna keep on dividing? Are we gonna keep on fighting? Are we gonna keep on dividing? Well, are we gonna keep on fighting? Are we gonna keep on dividing? Are we gonna keep on fighting? Are we gonna keep on dividing? Well, did you hear what I said? It's all about...
I remember the cartoon Galaxy High.
Galaxy High.
He went to school in space on a, it was floating around in space. That's what it's going to be like.
Mm.
For some people.
Well,
I mean, if you think about it, if you have your family, if their parents are in the Space Force and they are stationed like on the moon, there'll have to be some kind of school, you know, for their kids.
Space school.
Sure.
Mm.
Mm. That's interesting.
Space school is interesting.
Sure.
What do you think this sort of stuff they'll learn in space school?
Same stuff. I mean, I went to school I've been to school in the military, and there were students of parents who were in the military, or kids of parents in the military, and it's teach the same stuff. It's just the location is.
You're not that old, are you, Coach? I mean, like, I'm nearly 50, right? Late 40s. Are you that old, or are you a little bit younger?
Somewhere around 12,000 days old.
Right, yeah, brilliant. So, Fight the Flat Earth says he's about 30-something, or they reckon he's 30-something, right? So
12,000
nice. So he reckons he was taught non-Euclidean geometry at school, but what he means by that is that he was taught in school that straight lines curve. Were you taught that in school?
I didn't go to school.
You didn't go to school, and yet you can speak a few different languages.
I learned all those at home. Like Latin and Hebrew and Arabic. Hebrew and Arabic I taught myself, and Latin I learned at home.
Okay, well, have you learnt at any time that straight lines curve?
Straight lines curve? By definition, I'd have to say no.
Okay, by definition. Is that semantics?
It is a bit semantical, because in non-Euclidean geometry, straight lines are called geodesics, and geodesics do indeed curve.
Right, so that you were saying then it is okay for a straight line to curve then?
Well, like I said, but that's a stretch of, definition to definition. You have to compare. So just that statement alone, I would say, is wrong to say. The straight lines curve. But when you say, okay, in non-Euclidean geometry, straight lines are considered geodesics, geodesics curve, then therefore there is a scenario where you can say straight lines curve. But saying that statement alone, I think, is misleading.
Yeah, I think it makes you sound absolutely crazy whenever I hear anybody saying that. Because, I mean, as far as I understand it, you can have the space curving, but it's a bit of a stretch to say that the straight line actually curves, because the straight line, by definition, as you say, can't really be defined. It's so intrinsic as being not curved that you can't really say it's curved.
Well, I tried this before, and it was a little bit more hostile. So maybe we try it this time, because I don't mean this in
Hostile?
an antagonistic way. Yeah, but just like just defining straight line, because in Euclid even defines it in very, very specific terms.
Mm-hmm.
And I can ask you, but I don't mean it as like a gotcha. So if you want, I can look it up even.
What
the definition of a straight line is.
Something like a straight line is that which lies evenly between its extreme points. I can look it up. But
Yeah, I'm gonna look up. I'm also gonna look up Euclid's exact, because he has an exact definition.
Yeah, that's what I'm doing now, right? I'll look up for that. You look up for the non-Euclidean straight line definition and tell us what that says.
Actually, no, you actually said it exactly right. I think you
A
said,
straight line is that which lies evenly between its extreme points. I'm like nearly word for word that, right?
Yeah, it's word for word. And
what about non-Euclidean geometry then? Give us that one. The definition of a straight line in that.
There's one definition though that's also in Euclid about the straight line that isn't in the non-Euclidean, and that's the shortest distance between 2 points on a plane.
You mean with the postulates?
Right. Yeah, so it said there are some postulates that came later about straight lines. Says a straight line can be drawn between any 2 points, and then a straight line. Blah blah blah.
Yeah, because that's a postulate, right? Within the postulates are how the figures are made, right? How the actual drawings are being made. So it says, let it be granted that a straight line may be drawn from any one point to another point. So like anything subscribed onto paper, right, with a ruler, let's say, and a pencil. If you're going from one point to another point, then that's a straight line. That's all like that's saying, I think, myself. It's just how the geometry is drawn. That's what the postulates are to me, anyway.
Okay, what's the first postulate? I'm trying to find the one that says it's the shortest distance between 2 points.
No, that is that one I've just said it, but I mean it's not the shortest distance. It's just let it be said that a straight line can be drawn from one point to another. I mean later on that they kept changing it, didn't they?
Yeah, I guess you're right. And it might not just be Euclid's definition then, because it is also described as straight lines being parallel to one another. So like if you have 2 lines parallel to each other, they're never going to touch.
That's the parallel definition of definition 35, I think, but one. I'll give you that as well, if you want.
Yeah. So basically in non-Euclidean geometry, there's just some of those definitions are slightly tweaked. Like the straight line, it'll have some of the straight line definitions, but it won't be able to.
Can you give us some of them, Kosho?
Let me see if I can find some.
Yeah. Definition 35 is parallel straight lines are such as are in the same plane and which being produced ever so far both ways do not meet. That's definition 35. It's not an axiom or a postulate. That's within the definitions. And the definitions get proved within the geometry. So did you know it was a definition, the parallel line thing? Or did you think it was just an axiom?
Parallel postulate.
Yeah,
Hold on.
No, this is the definition. The parallel postulate doesn't really mention parallel lines because that's like imagined into it. But yeah, the parallel straight lines are such as are in the same plane and which being produced ever so far both ways do not meet. That's the definition. Fight the Flat Earth was saying that parallel lines intersect in non-Euclidean geometry as well. Right. Can you find that? So with the definition where it says straight lines can curve and that parallel lines intersect, please. So you're like all on board with this Fight the Flat Earth geometry, right?
Yeah, I don't call it that though.
What do you call it?
Non-Euclidean geometry.
Yeah, well, I mean, it's obviously not Euclidean. I mean,
it's called non-Euclidean geometry.
Yeah, but that's what everything that isn't Euclidean geometry is called, right? Because there's only Euclidean geometry that's called Euclidean geometry. Anything else that isn't that is called non-Euclidean geometry.
Well, Euclidean geometry is pretty profound in its it's factual, but it's not. It doesn't refer to curved spaces. So in curved spaces, you don't use Euclidean geometry.
Curved
So curved
spaces.
spaces and non-Euclidean, yeah,
Yeah.
like hyperbolic or
Yeah, that's the space that's bending, right? Like, because Euclidean geometry, right, deals with real life sort of geometry and straight lines. It does do curves, it does circles and all of that. So, I mean, of course, it does curves. It even does spheres and solid geometry. So, it even does that sort of a curved surface. So, what you're talking about is space curving. Right, and it doesn't talk about space because it's just talking about the actual geometry and the lines and the shapes and stuff.
not quite. Like circles, you can talk about them drawn on to flat surfaces, and that's still Euclidean geometry. But if you were to talk about a circle drawn on a spherical surface, on the surface of that sphere, then you wouldn't be able to use, Euclidean geometry for it. So you can draw curves on flat space or flat planes, and it'd still be Euclidean.
Isn't spherical trigonometry? That's like based on Euclidean spheres and stuff, right?
Well, yeah, no, it's like if you were to make a sphere in a 3D coordinate system, you'd still be using Euclidean geometry because you're describing it in flat.
Because a sphere is only ever described as a shape within Euclidean geometry, right? You're not showing me the straight lines can curve yet. Definition of that. You've not shown us the thing that says parallel lines can intersect, and you won't be able to show me a definition of a sphere within non-Euclidean geometry, will you?
Well, non-Euclidean geometry is talking about the surface of a sphere, so you're not really going to be talking about a sphere on the surface of a sphere.
See, you just said non-Euclidean geometry again then, and you said on the surface of a sphere. That's not being very succinct, is it? Because that's not non-Euclidean geometry. You can define it better than that, can't you?
I mean, it's really any curved surface. So a surface of a sphere is one example, but
yeah, that would be specifically spherical geometry, right?
Yeah, you can call it spherical geometry.
Okay, right now, when we were just talking about you finding the definitions, and you said you weren't going to call it like the flat Earth geometry. You said you were going to call it non-Euclidean geometry. Then you sort of flipped to spherical geometry. Now, there are no definitions in spherical geometry that tell you that straight lines curve, parallel lines intersect, are there?
Nobody ever calls it the flat Earth geometry.
But listen, in spherical geometry, there are no definitions for straight lines curving.
I'm trying to answer your question.
So it's not spherical geometry that we were just talking about earlier.
Right. Do me a favor. If you ask a question, just let me answer it, okay?
Okay.
Because this is when it gets aggravating.
I was just making
you start speaking over me.
But I was just trying to make it sure that you're not going to redefine something that I'm just already explained to you.
I'm trying to answer your question.
Okay, go on.
Yeah, so non-Euclidean geometry is a set of different curved surfaces. So you can be talking about any curvature where the surface is curved. And so spherical geometry is a subset of non-Euclidean geometry. So to put those two things together is not wrong to do. What I was saying I wouldn't do is call it the flat Earth geometry, which is, I think, fair. But we were talking, so if you want me to pull that up, I can pull it up. So
yeah, please, can you find us some definitions of the straight line curving and parallel lines intersecting? Because, like I say, I'm pretty sure that that's not within spherical geometry. So that's why I'm saying, when you just say it's not Euclidean, I'm completely agreeing with you, because straight lines are straight and parallel lines do not intersect. So please find us those definitions, because it's been stated by quite a lot of people just recently that this is acceptable to just state these things. And you say you don't like to call it Fight the Flat Earth Geometry. I just call it that because he's the first person I ever heard say it. And ever since then, a lot of people have told me that, yeah, it's right. So I just presume that they've heard it from him. And you're just
That's
parroting
very strange
what you've
presumption.
heard from Fight the Flat Earth. Well, can you show me the definition? Because, again, who's been telling you this is true? I mean, like, have you read it somewhere within a
places.
textbook?
Have you ever read about non-Euclidean geometry?
Fight the Flat Earth says he was taught it at school. Now, I say I've never been taught it at school. I never was taught it at school. As far as I understand, straight lines do not curve. They never will, because as the moment they do, they then become a curve line. If a straight line curved, there's no way to differentiate between a straight line and a curved line. So that just sounds ridiculous to me. It doesn't logically work, which is the framework of geometry is a logical framework. And if you have to step out of that logic in order to understand Fight the Flat Earth geometry, seems like you can just call something not Euclidean geometry and then make up something and not have a definition or a postulate or an axiom or any sort of fundamental understanding of it other than knowing it's not Euclidean geometry. I mean, that gives us a bit of a hard time, right? Because we're looking at the geometry book and going, well, I completely understand this geometry, it makes sense, but you're just saying it's not this geometry, it's something else, and making stuff up as far as I can see. Because surveyors use Euclidean geometry, right?
Geodesic surveyors, of course.
Pardon?
Geodesic surveyors, I believe, do not.
Oh, what geometry do geodesic surveyors use?
I think you can guess. I think they call it Fight the Flat Earth geometry.
I hope so. I hope they should start doing that, yeah.
You think just because you heard something for the first time from Fight the Flat Earth that everybody else has?
But the straight lines curve. I mean, it sounds illogical, but I've heard Fight the Flat Earth say it, and then I've heard a lot of other people say it. I've never seen anyone show me a definition that says straight lines can curve in this other geometry that has a name other than not Euclidean geometry.
I posted something I'm trying to read, but trying also to listen to at the same time. So I posted it just so maybe you can read it too.
Was that in?
But
Where'd you
it's
post it?
probably going to be in here. So let me go through this.
Oh, Walter Bislett. Oh no. Wait a minute.
Hold on. So the one that I'm looking at is or the person I'm sorry that I'm looking for in here. Damn it, hold on. Yeah, right, is Tannery. So there's probably a lot of different biographies on here. I'm looking at Tannery's.
Where Tannery? What year did he come into it?
I'm not sure.
Because didn't that dude Aristophanes do something?
Yeah, it was 2,000 years before him.
So what geometry do you suppose he used?
I wouldn't consider him using either of these geometries. He was just using the
What do you mean he
He was
didn't
he was
use any
using
geometry?
I wouldn't consider him using non-Euclidean Euclidean geometry. He was just using the definition of a circle.
A circle?
Mm-hmm.
Oh. Do you reckon he could measure angles to curves? You find that?
Yeah.
Find the thing of that for us as well.
Yeah. I think when thinking about the definition of a circle, defining the angles in reference to the distance along the circumference that they measure out to. Yeah, I think he that's the sort of geometry he's using. But that's regular geometry.
Regular geometry.
Mm-hmm.
Yeah. You know, geometry, the etymology of the word is.
Yeah, it's measuring the earth.
Yeah. So if Eratosthenes was measuring the earth, with geometry, which geometry do you think he was using?
Well, non-Euclidean geometry didn't come about until about 2,000 years later. So
Okay, so he was
geometry was
definitely using Euclidean geometry then.
Well, like I said, I think it's just called geometry at that point.
Yeah. Yeah, it probably was. Can you explain how he measured?
Measure the earth, yeah. Simply,
Yeah.
he had one point, which was the sun was 90 degrees above that position. He measured another point where the shadow gave him what is it, 87 or 82.5 or 82.8.
What was he referencing? Was he referencing a vertical or a horizontal?
Just the shadow. So shadow from straight up 90 degrees. So it would have been perfectly vertical.
Ah, vertical, right? Yeah. So that you'd have known it was 90 degrees because it was perpendicular to the horizontal, right?
Well, because there was no shadow.
Yeah. But two straight lines in order to measure an angle.
He's just using the shadow. So the triangle's made by the shadows.
Yeah. And the triangle was made of three angles, which was made of the inclination of two straight lines or planes towards each other. It would have been planes, right? Or a plane and a straight line.
Yeah, he didn't get as confusing as you're making it. It's just measuring the shadows,
No,
triangles that were
it's
made.
defined within solid
angles made by
geometry
the
in book
triangles.
11 how you can measure an angle between a plane rectilinear surface, right? It's all in there. How to measure angles.
He didn't have that.
Pardon?
He didn't have this, so he did it much simpler.
He didn't have
He
what?
just defined the angles made by a triangle using the length of the stick, the length of the shadow,
Yeah.
the invisible
Two straight lines
hypotenuse between
to
them.
measure the angle.
And they were generally straight lines.
There are always straight lines in between angles, aren't they? The angle is the inclination of one straight line or plane towards another. It's got quite a few of them. A straight line is perpendicular or at right angles to a plane when it makes a right angle with every straight line meeting it in that plane. Well, that's even more exact than the earlier, like just line geometry, right? This is in book 11, solid geometry. A plane is perpendicular to plane when a straight line is drawn in one of the planes perpendicular to the common section of the two planes are perpendicular to the other plane.
I found this great. This is a great definition here for the Euclidean geometry. Because I was during this conversation, I've been looking for that. This one suffices.
For Euclid.
It talks about
Or non-Euclidean,
Yeah.
did you say?
It talks specifically about the difference between the line on both Euclidean and non-Euclidean, and then it also discusses two subsets of non-Euclidean, including spherical and hyperbolic.
Parallel planes are such as do not meet one another, though produced. Solid angle is that which is made by more than two plane angles which are not in the same plane meeting at one point. So where did you say your one was?
Say again?
Did you say you got us a definition somewhere?
Yeah, it just has the distinctions between Euclidean geometry, non-Euclidean geometry, spherical, hyperbolic, and it does it in the context of straight lines and how straight lines differ.
Does it say that straight lines curve?
It says that they intersect and do this and that.
Straight lines intersect in Euclidean geometry as well, don't they?
No, parallel straight lines don't intersect in Euclidean geometry, but they do intersect in non-Euclidean geometry.
Where does it say that?
Let's see.
I thought it was an axiom that there are no parallel lines. So
Well,
having parallel lines then intersecting seems a bit.
Well, that's the point, though. Is that if you start them out, so you do like strings or something. If you had strings that you tried to make parallel, you'd find them intersecting, so they wouldn't.
Yeah, so they wouldn't be parallel, right?
Where there's no, like you said, there's no parallel lines on it.
Right. Yeah. So why would they have a built into the geometry that parallel lines intersect?
Well, what I meant to say was lines that you.
No. You. That's what Fight the Flat Earth said. That's why I called it Fight the Flat Earth Geometry.
I'm not Fight the Flat Earth. You don't have to keep bringing him up, man.
No, but I'm saying he says that parallel lines intersect in his geometry. You said it earlier too.
I just corrected myself just now.
Yes.
I said
Now, okay. So now you've
lines
backtracked from what I'm calling Fight the Flat Earth Geometry because he
call it whatever you want.
he says that straight lines curve within the definitions.
I have like a thing with Fight the Flat Earth. Like if you want to talk to him, dude. But I'm talking to you. I'm not bringing up Fight the Flat Earth. If I said something,
I'm saying
what I meant
you seem to be parroting. You parrot what he says.
What I'm saying. I don't listen to him.
But you
You're the
all
only one here
like you
obsessed
must
with
hear
I
it
don't listen,
sort
I
of
don't watch the
through
show. I don't watch the
osmosis
show
or
at all.
something. A bit of diffusion from all of the trolls saying it that follow
telling you
him,
the
and then
difference.
they come and tell you and reinforce it to
I'll tell you
you.
the difference between these two.
Yeah.
If I said that, if I said parallel lines, what I meant to say, what I'm telling you is I said it incorrectly. Not parallel lines, because you're right, they don't exist. What you said was correct, they don't exist. But if you did what you needed to do
I didn't
in
say
reality,
they don't
was just take two
exist.
Dude, hold on.
You know,
Take
you
two
just said I said that they don't exist. I didn't say that.
I just said just like you just said. You said in non-Euclidean geometry they don't exist. That's what you just said. I said you're
within
correct.
the axioms of spherical geometry, it states there are no parallel lines.
Why are you repeating it slowly if I just said that you were correct?
But you mashed up my words into getting me to say something else that I didn't say.
That's okay. Yeah, you're saying in their axioms.
Yeah, in your axioms for the geometry that you want to use.
You're correct. So if you'd let me finish what I'm saying, so that you don't have to, and don't bring up Fight the Flat Earth anymore, dude. Like you're the only one here who watches him. I don't watch his show. So if you tell me I'm getting something from him, it's nonsensical. I don't watch his show. But you're right what you said, that parallel lines do not exist in the axioms of non-Euclidean geometry. What I meant to say was if you did what you needed to do to make parallel lines, like if you start out two points and went in the direction that were parallel to each other, and you kept going on those two lines, you'd find them intersecting. And so they would not be able to say that they were parallel, even though you did exactly what you would need to do to create parallel lines.
Like latitude lines. You're saying?
Well, no, like longitude lines.
Oh no, but latitude lines. Would you not say they're parallel?
I would say they're not lines. They're not straight lines.
No, I didn't say straight lines. I mean, there's no straight lines on a sphere. I mean, everybody knows that, right?
There are geodesics. Like longitude lines are geodesics.
Yeah, but they
latitude
don't
lines
call them straight lines, do they?
You just did. That's what I'm saying.
No, I
I'm
didn't
not
call them
working.
straight lines. I just said latitude lines. Would you call them parallel? Is what I said.
Latitude lines are parallel planes, but they're not straight lines. They're curved lines because they represent
Okay. So
parallel
there's,
plane.
but there, if it has in the axioms that there are no parallel lines, then do you not think it's a bit weird that you've just said there are parallel lines?
I said they're parallel planes, is what I just said.
Planes? You think there's such of a thing in spherical geometry as a plane? Can you give me the definition within spherical geometry of
It's
a
not spherical.
plane,
We're not talking
please?
about spherical geometry at this point.
You're not. So
I'm
you're
telling you
talking
what
about
the
fight the
design-
flat Earth geometry now, are we?
Bev, this is going to end very quickly if you keep interrupting me to bring up Fight the Flat Earth.
Well,
I'm saying something. Just let me finish what I'm saying.
please name your geometry.
A sphere in coordinate space. You can use Euclidean geometry to describe this. A sphere, if you were to take parallel planes and slice it up, you would get the latitude lines because that's what it's lines that are created
So
by
that's Euclidean then.
planes. Well, I mean, you don't have to make a distinction. You don't have to say that. I'm saying in a
Yeah, I do.
coordinate-
I make a very good distinction because Euclidean geometry is very well defined.
We're not talking about the surface of the sphere. We're just talking about a actual sphere. If you were to take any kind of plane and
That's
slice
Euclidean
it,
geometry. I'm quite fine with that.
Jesus Christ. You like to hear your own voice, man. So you just keep talking.
But your geometry that you're doing, like we said, I call it fight the flat Earth geometry because he states things like straight lines can curve and parallel lines intersect. What about, have you heard the one about triangles? In spherical geometry, the sum of the angles of a triangle is always greater than 180 degrees. Always. So, can you name any time you've ever heard of a triangle and somebody's told you that the sum of the angles of the triangles that you're going to measure within trigonometry or whatever is always above 180 degrees? Have you ever heard that? Because I bet there's loads of people that haven't. Because as far as I'm aware, triangles have 180 degrees in them. Internal angles. So that would sort of negate the fact, wouldn't it? I'd say, well, I can't be using that geometry. If that's one of the rules of the geometry that states the sum of the angles of a triangle is always above 180 degrees.
You ever seen this riddle before?
Riddle?
Yeah, I like
Let's have a
riddles.
look. You like riddles? You think that's what this is?
No.
The geometry.
But I posted a riddle though that's in relationship to what you're talking about.
Yeah. Do you think this is? I think this is some sort of fantastic.
This is in direct relationship to what you're asking.
Is it?
Yeah.
90 degrees. Can you tell me how you would measure that angle of 90 degrees?
Simple. In this riddle, she's making 3 90-degree turns,
Yeah.
ending up in the same spot.
Okay.
So somehow she made a triangle that was 270 degrees.
It doesn't.
much
I don't
greater than
think so.
180.
She's just. No, she's not. She's just turned 90 degrees.
Right, but she ended up in the same spot.
It doesn't say that.
It does.
No, it doesn't. It just says
says
she
she
finds
tent.
outside her tent. I mean, she's
That's
got
right.
two
Leaves her
tents.
tent- And she travels a mile.
She's
She does
got
that
2
2 times.
tenths.
She ends up back at her tent. After,
Yeah, she's got
she
2
makes
tenths a
one
mile
turn.
apart.
Yeah, well, this is not what it says. This is the same tent.
No, it says that
That
woman
shouldn't be-
leaves
that
her
shouldn't be a
tent,
mystery.
travels 1 mile directly south from there. She turns 90 degrees and heads east for a mile. And then she turns 1 mile and she turns 90 degrees. So she heads south, right?
She's heading north again.
South. Well, she heads north then again. Yeah. Because she needs to go west in order to go back again to that spot, doesn't she?
It would seem so.
Yeah. So she's
Travels
got
a mile
2
south,
tenths.
And she goes east and then goes back north, and she's in the same spot.
Yeah, she's got 2.
She's made a triangle and ended up at the same spot.
No, you can't. You see, you can't do that.
Well, that's what the question is.
You can't make a triangle with more than 180 degrees. You can't do it.
That's what makes that answer easy. Otherwise, you wouldn't be able to know what color the bear is. But there is a place where you can do that, actually. It's a specific place you can do that.
Hang on
And
a
there's
minute,
only white bears
Kosho.
there.
Kosho, hang on a minute.
Mile.
This mile triangle that you're talking about, this should be scalable, shouldn't it? It should happen at any scale.
Triangles are congruent. Yeah, that's the
Any
way
scale at this
it
position.
occurs. And
So if you did this at any point on your globe, then this should always happen.
This position, yeah.
yeah, it's 1 mile.
So if I walk 1 mile in a straight line, turn 90 degrees, walk another mile in a straight line, turn 90 degrees, walk another mile in a straight line,
Yeah.
then I should end up where I started.
No. You'll be a mile away from where you started, won't you?
No, hang
There's
on.
one
Let Kosho answer.
Surely you can only make a box with 90 degrees angles.
It's a square shape. Kosho, right?
Yeah,
The place where this works is the North and South Pole. There's no bears at the South Pole. So, it's
no,
North
hang on,
Pole.
Kosho. Hang on, Kosho. Your sphere curves equally all over the place. So if it works in one place, it should work everywhere.
It doesn't work like that. If you have,
That's rubbish.
no, it's just if you walk directly
That's rubbish,
south.
Kosho. You are
walk directly
talking
south.
complete toilet.
You guys
now.
talk to yourselves. You guys talk to yourselves.
Well, I'll talk to you. Don't worry about it. Yeah, he's absolutely crazy, right? A
Yeah,
90 degree is what is known as a square, right? In the building, that's that tool with 90 degrees. It's called a square, and it's because it has 90 degrees in it. Right? It's the 2 lines are perpendicular. It's very, very well defined within Euclidean geometry. That 90-degree angle.
Evening, Spawn.
Yeah.
Morning, I was going to say morning then. Yeah, no, it's two parts of the triangle, the square.
Yeah. Yeah, I mean, like it's like quite common for people to think that triangles, but it is actually a proof that because you've got 3 lines here. Kosho's just shown, right? They're all 1 mile long, and you've started and you've gone 1 mile and made 1 straight line. You have then made a 90-degree turn, and you have gone another mile, and then you've made another 90-degree turn. So them 2 turns that you've just made, 2 90s add up to 180 degrees, right? But now you've got to make a triangle. Now you can't get those 2 lines to meet, because you've already used your 3 sides, but you've ended up with 2 parallel lines that will never meet. So I don't understand what you're talking about, Kosho. You'd have to...
Maybe explain it to me.
You'd have to have a definition that shows that you can have an angle to a curve within your geometry. Now, I presume you're using some sort of geometry that's got definitions in it, and you're not using Fight the Flat Earth geometry, which nobody seems to have any definitions for. Just people seem to sprout bullshit about things that people mean, like straight lines curving and parallel lines intersecting. And we may as well add to the thing how to draw an angle to a curve, because that seems intrinsic to some sort of spherical geometry, the angle to a curve, because you need two straight lines for an angle in every definition that I understand. But that's similar to a straight line being a straight line. I only understand that because it's fundamental logic that dictates it.
The thing that does me in as well, Bev, is that like everybody's saying about spherical geometry, hyperbolic geometry, yet nobody can give definitions for anything to do with these different types of geometry.
Bev, you have another guest in the house.
Oh, we got some backup. Is he called
Funk.
somebody in? Oh, Funk.
Is it? Oh.
Funk.
Has he got a voice?
Yes, he has a voice.
A nice sunset. Is he, have you been called in, Funk? Has Kosho called you in?
Hello? Well, what the fuck are you talking about?
No need for swearing.
Hello? I can hear you. Very low, though. Do you want me
Can
to
you
turn you up? I'll turn you up just a minute.
You have to decide that for yourself. I cannot hear my own voice.
Okay.
You
I've
keep a
turned you up
swear
a
words
bit.
as well, Funk, please.
I didn't swear now.
I thought you did, sorry.
I swear the last time. Sorry about that.
Yeah.
Have you been called in, Funk? Is Kosho?
Called in by who? Who's
Kosho.
there? No, I haven't talked to Kosho in a long.
Okay.
How are you, Kosho?
I'm good, Mr. Funk. How are you?
I'm good.
Do you have? Do we have straight curved lines? Are you? We may as well start off with the basics, right? Do you believe that straight lines are straight, or do you believe they have a little curvature to them?
Straight line is a straight line.
Okay. But I mean, that straight line is a straight line, right? It doesn't have any curvature to it.
Straight line is a straight line. Curved line are curving.
Okay.
Never the two shall meet.
What about triangles with more than 180 degrees?
Oh, you mean like in Euclidean geometry or something like that?
No, Euclidean geometry and all known geometry has triangles with 3 straight sides, 3 angles that total 180 degrees. It's provable, right? It's a relationship between a triangle and a circle.
Yeah, on a flat plane it works, but I don't think it works depending on how you define that triangle to be.
Right, well, a triangle, like, here we go. An angle, a triangle is 3 angles, right? Now, those angles are defined by the inclination of 2 straight lines or planes to each other. So, a triangle, by definition, needs to have 3 straight sides and 3 angles.
Yeah, that's a triangle.
Characteristic of having 3 straight sides is them having 180 degree internal angles. Do we get a yeah or a?
Sorry, I thought I dropped out.
I don't think you did.
Yeah, triangle.
3
They have
straight
3
sides.
straight line.
So we can't call a triangle on a sphere a triangle because it hasn't got 3 straight sides. So we'll have to call that a spherical triangle from now on, right? To differentiate it from a
I think it has
normal
a name.
triangle.
I think it has a name when it's like a slice, triangular slice of a spherical shape. I'm not sure what the name is.
You mean a slice? But that wouldn't be
Yeah.
spherical geometry, right? Because the spherical geometry is the geometry of the two-dimensional surface of a sphere. Right? You can't cut into that surface, can you? You can't make it a 3D surface, because then it would be the three-dimensional surface of a sphere, which is Euclidean.
Yeah, but it sort of is, though, to describe the surface of it.
The surface of a triangle.
The triangle which you took out from the sphere.
The triangle that you took out from the sphere. Yeah, I think you're getting mixed up between your different geometries, right? If a triangle has straight sides, then it's a triangle and it has 180 degrees. If it doesn't have straight sides, you can't really call it a triangle. Not in my world, anyway. I mean, in some sort of concept, right? Where you draw tangents in order to divide the angles up.
Well, if you're gonna use the, I'm not sure what what you call that, those fucking could you call it laws of triangle, if you want to call it, how you can calculate the different angles. That only works if the triangle is shaped like
Euclidean.
that, because yeah, I'm talking about being on a flat surface.
Yeah, that's a triangle with 180 degrees. Well defined. Everybody understands that. Everybody knows that's one of the laws of geometry, right?
Mm-hmm.
Okay. So triangles have straight sides, and we did agree at the beginning that a straight line definitely isn't a curved line. And since we've agreed that a triangle is 3 straight lines, then it can only be 180 degrees, because that's provable within geometry that a triangle with 3 straight sides, as defined by triangle, 3 angles, can only have 3 straight sides and therefore 180 degrees internal angles.
Yeah.
Yeah.
Like the way I look at it, if you draw a triangle on a spherical shape, and you were to somehow make it flat, that will not be a triangle anymore.
Yeah.
It wouldn't look like a triangle. It would look like a bloated triangle, basically.
Yeah. Because a sphere is a non-developable surface, right?
What do you mean by non-developable?
It means you can't develop it onto a plane surface without distortion.
Yeah, that's true. Yeah.
That's why all maps are to scale, right?
Yeah, maps. Yeah, it's impossible to basically create a rectangular map out of a sphere.
Yeah. But all maps are to scale, right?
What do you mean by to scale?
Well, do you have a scale on them, like the maps?
Yeah,
1 to 50,000 or something like that. Yeah, it's not. It's no
like
different,
yeah,
is it?
yeah.
I mean, there's no distortion across that scale when you get a map, is there?
If it's a world map, then it would be.
No. I mean, like yeah, but you wouldn't use that. Like, I use the Ordnance Survey maps in the UK, and they come with a scale on them, right? Now that scale is same all the way across the map, isn't it?
Yeah.
Yeah.
that is true because as
It's because it's been made
if
from a
you take,
developable surface, right?
if you take a slice of the sphere, and you just take a tiny bit of it, it's almost plain already, so it wouldn't change
Yeah.
that
But
much.
the surface of a sphere is a non-developable surface, right?
What do you mean by that?
Well, you just agreed just a bit earlier, right?
Oh, you mean it's if
A sphere is a non-developable. I hate that word.
Yeah, you mean if you stretch it out on a plane, it would distort. Is that what you
Yes,
mean?
yes. They're
Yes,
within,
I agree to that.
say, Gaussian curvature model.
Yeah.
Yeah. Then there are certain shapes and all of that are called developable surfaces. Things like cylinders and cones and all of that sort of stuff,
that's
right?
true.
Yeah. And a sphere is a non-developable surface, which means you can't develop it onto a flat plane without distortion.
Yes.
Yes. And
You
maps
said that-
are on a flat plane, but they aren't distorted, are they?
Soon.
Okay.
I have to go in soon. We agreed to everything. I have to go in soon.
You have to go in.
Maybe. Yes, I have to go in.
He's calling
And,
you in.
Yeah. I've just been to the store and I cannot keep talking this all night.
Okay. Sweet.
So I'm just wondering if there was like a. What are we talking about actually?
We're talking about people making up new geometries just because they feel like I don't know, they get stuck with reality, right? But they can't have reality, so they just make up geometries which they imagine to be true.
Okay. What kind of geometry did people make up?
Well, like we've just been expressing, Fight the Flat Earth has made up a geometry where he says straight lines can curve. He says it's within the geometry, and parallel lines can intersect. He's borrowed a few of the ones about the triangles with more than 180 degrees as well, which I find fascinating. But I've heard Gem Panda say that triangles can have more than 180 degrees. In fact, I've heard quite a few people say it. Yeah, are they crazy, or are you going along with that? It's
depend if they are talking about on not a plane surface, then yeah, it would have more than 180 degrees.
a triangle.
Yes.
Yeah. Okay.
So
And what about straight lines? Are you believing that people can just make up a geometry that isn't Euclidean and say, in this geometry I'm just making up straight lines curve and parallel lines intersect? That's a good one. That's one of the best ones I think I've ever heard.
Yeah, but I think they're talking about the lines. If you are representing them in that way, it will actually intersect each other. Even if they are parallel on paper, it would not be parallel on the spherical shape.
So you're allowing for parallel lines intersecting being a part of this new geometry that you're making up with them? Or is it because Fight the Flat Earth has said it that you're sort of agreeing to it now, or?
No, I'm just using my intuition now, actually. I'm not so very good with it, but I'm just using my intuition now.
Okay. And that intuition is telling you that you should go ahead with making up that it's okay for parallel lines to intersect.
Well, I am not gonna say whether some guy named Fight the Flat Earth is right or not. I have not seen what he has done. But it's probably possible to express that type of geometry mathematically in some way, and make some equations on how to calculate the different angles between them.
Okay.
And the
Can you just give us off the
length
top of
of
your
the
head
line.
now? What's a parallel line? What's that mean?
Parallel lines are two lines which are a certain distance between each other, but they are moving along the same. How should you say? Yeah. You understand what I mean?
Yeah. I mean, the parallel. They never intersect. They never touch. They stay the same distance apart continually. Now, can you just imagine somebody that's willing to make up a geometry that says that those parallel lines that everybody understands that don't touch actually intersect? And then on top of that, go along with straight lines curving. In fact, both of them might be a consequent of each other. I mean, what do you reckon? Do you reckon if you're crazy enough to say?
On how we represent it, though.
Yeah.
I'm not sure how we represent this geometry. But
No, you just
if
make it up, right? Nobody's ever shown us a definition of any of this stuff. People like you will try and make your own definition and justify it for him.
If it's provable that it's working, then I guess it's fine.
If it's provable.
Yeah, if it's math, you can prove it. So.
Okay, so do you think through mathematical means you can prove that a straight line curves?
No, not that specifically.
Okay.
I'm talking about this a way of representing geometry.
Well, yeah, like Euclid did it with a load of definitions. Did it through an axiomatic system, right? With a load of definitions and then the axioms and the postulates. And then he lays out the propositions, which prove everything that went before it with the definitions and the axioms, right? The proof's all there within a one self-contained system. So that's Euclidean. That's how normally or normal people would express geometry, I would say. I'm a bit concerned with the fact at the minute that there are people that just make up not Euclidean geometry with no definitions or anything, being able to cite anything, and state ridiculous things that straight lines can curve. And then there are other people that come along and defend that by saying that you don't know how clever he is. He might be one of the most forefront geniuses, so you're not willing to argue against him. Does he have? Are there some people within your side?
On the top of my head, I would guess it's not that hard to figure that out, to express it in any way. I mean, I'm not sure if it will. It's probably we're able to create some form of generalized expression on how to do that. I think that's not that hard.
Really? It's not hard to make a new system of not Euclidean geometry.
It's equations. This is not
equations.
It has a basis in a sphere, so. If you can express
a sphere is a Euclidean shape, right? A sphere is defined within Euclidean geometry. Because I bet within your geometry that you're imagining, like the flat Earth geometry, you can't even define a sphere within it. I mean, you could be writing it. You should be helping him now, right? I bet he's taking notes. I bet there's a load of people now scrambling to help him.
I would have to watch the video. I'm actually a bit curious what he's been doing. I'm gonna watch his video.
Well, there's loads of them. I mean, like, you imagine that there's a level, I suppose. You know the word level. Do you imagine that has a curvature to it?
Well, it depends on your on what you mean by level.
Well,
How do you define it?
Gem Panda says everybody knows what sea level is. Sea level's been used forever, right? So everybody
Yeah,
understands
pretty
what level
much.
means because of that, right?
Yeah.
So what does that mean to you? Because level to me means horizontal.
On the short scale, I would say that that's pretty correct. It looks pretty horizontal over, like, in a house. If you're gonna build a building or something,
Yep.
doesn't really matter. You can have a laser level in the middle of the room, and even if the middle of the room is where it's you're calibrating the laser level at, it's gonna create a circular laser around the room and say this is the same height everywhere in that room. And if it's 5 meters away from it, then it really doesn't matter if it's 1/100th of a millimeter wrong, right?
Okay, in a room, but I
Then
mean,
if you
like,
go,
we go bigger
sorry,
than that, right?
if you go bigger than that, then you might have to take that into account.
Take
That
what into account?
That level will change over that distance.
What do you mean change?
It will not be the same angle. It will not be a horizontal line. It will change.
On a tilt, do you reckon?
Not tilt sounds like a straight line. It's a curving line.
Oh, the horizontal.
No, we're talking about level now.
Pardon?
We are talking about level now.
Yeah, but you just said it was horizontal.
No, I said it will look up horizontal in a short.
Okay.
Short
Yeah.
scale.
So what you're saying is that when you say level, you mean the level will drop away from horizontal?
Well, it will appear to drop away. Yeah.
Just
from
appear
that
to.
horizontal. Yeah.
Oh.
If you mean to drop away, if you want to say it like that, yeah. Its angle is gonna change.
Of the angle
Like,
of the horizontal, right? So,
between the level.
but you just said it's curved. How do you have an angle to a curved surface? I mean, what's that about? How do you do that?
Because it's curving gradually from where.
Okay, so do you have a
the
definition
original
of
level.
where this geometry is that you're now using that has an angle to a curve, please? Because I take it that the angle you're measuring it from would be the horizontal, right? So that's
Yes.
one straight line. Now,
Yeah.
the other one, the line that you were imagining is there, is a curved line, is it not?
Well, if you're gonna measure with a level for every meter, then that would curve.
Is
over,
it curved?
Yes.
Okay. Now, have you got a definition of a measurement of an angle that can be taken between a straight line and a curved line, please? Because all
Depends if you're
angles
measuring-
that are measured are taken between two straight lines or planes, or a combination of the two. Straight line to a plane and a plane to a straight line, or between two straight lines or between two planes. But neither is there a curvature to anything.
If you use that level at a certain spot, you can create a tangent line from that spot.
But
That could be
the
your
spot that you
reference
do
point.
that is called horizontal. and that is where you are measuring the angle from. So it is horizontal to horizontal, and that is not the definition of an angle. In fact, it's stated within the definitions of Euclid that it has to be a separate straight line. Otherwise, you cannot have an angle. So, once
You're
again,
saying that the two
please,
horizontal lines are parallel?
if you are trying to measure the angle between the point where it is touching the level, which you say is horizontal, there will be no angle to measure. Surely you must see that.
I understand what you're thinking, and I understand why you're saying that. But these two horizontal lines are not parallel. Horizontal is a definition we use for something that is perpendicular to
So,
our...
are you saying you've got to measure the angle between the horizontal and the horizontal?
I wouldn't maybe use the horizontal in that case, because it can be confusing. You can use a different word for it if you want to.
No, we're going to use horizontal because it is perpendicular to vertical. We're going to keep everybody understanding what's going on here, right? Yeah. The vertical is a straight line, and the straight line perpendicular to it at right angles is called the horizontal.
Yeah.
Okay. Now,
the
horizontal and the vertical is where you make measurements from.
If that changed, then...
So, where is the angle we are going to be measuring this from? Please.
You're measuring in that at the 2 points of observation.
The point of intersection.
Yes, you could say that.
Okay.
Where they intersect.
Okay. So where they intersect is perpendicular, right?
Let me ask you a question.
They intersect at the point where they are perpendicular. True?
Do you understand what I'm saying now?
I'm trying to get you to just confirm that they intersect at the point of intersection, right? So the vertical is 90 degrees to the horizontal at that point.
At that point, yeah.
Yes, okay. Now, at that point, where is the angle that you are measuring? Please.
You would have to have a second point to measure an angle against something.
Okay, so we are going to be using that horizontal line as a reference to measure an angle from.
You could say that, yeah.
Okay. Now, were we going to be measuring an angle to?
As I said just right now, a second point.
Okay, so.
And you find the perpendicular. You find the vertical there at that point.
Yep.
And perpendicular to that vertical, you have what you would call horizontal.
Yep.
So you have two horizontals.
Yep.
Which are at two different places on Earth.
Yes. Both of them perpendicular to the vertical.
Yes.
Okay.
And they should, if you're following flat Earth model, then they should be parallel. But
the flat Earth model. What's that?
It's a model with a flat Earth.
With like a two-dimensional plane. Flat.
Yes.
Okay. Right. So there's no verticals on that, is there?
Are very
it's two-dimensional, so there's no vertical, so you can't measure a height. So that model obviously won't have anything to do with perpendiculars or verticals, because there's no vertical on a two-dimensional model, is there?
Oh.
No, so let's not use that model. Let's use reality model, right?
Oh, I would say it's the surface of the Earth is flat.
Okay.
On a flat Earth model.
Okay. Well, let's say
say
we've done a vertical.
You can still
Like,
use
say we've
airplanes
done a
as
vertical and a horizontal at one
Oh,
point,
think it's what
and then we've moved a mile away. In reality, right? And we've done the same. We've put a vertical and a horizontal. We've established a vertical and a horizontal at 2 places a mile apart.
Yes.
Yes.
I think it's literally
Okay.
the 10th time we are saying this now.
Yeah, I know. Well, we're just getting the picture in everybody's heads, I'm sure.
I understood what you said the first time, actually.
Okay, so what happens to these horizontals that we've just made that are a mile apart?
What you mean by happens? They are there. Created a fictitious horizontal line.
Yep, and we've got 2 horizontal lines and 2 vertical lines.
Mm-hmm.
Now these horizontals, are they parallel or do they intersect? What's occurring in your geometry model?
They are not parallel.
They're not parallel. Is that because you have a geometry model that states that they're not parallel, or is that because you imagine that they're not parallel, or is that because you've actually measured that they are not parallel?
I haven't used any measurement to measure this.
Okay.
But others have.
Okay, but what are you going with? You're imagining a geometry that this happens?
Are we talking about the measurements of reality now? Or
Yeah, we're saying it was just a mile apart, and we've just done a vertical and a horizontal, because we can do that, can't we?
Are we comparing the ideas of a flat Earth and a spherical?
No, we're taking what would happen in reality.
You do realize we can do this without actually living on a Earth at all.
Yeah, we can do this. Yes, we can do this in reality. That's what we do here.
No. Okay.
Oh. Is he
It does have nothing to do with what is actually reality or not. Reality is what we measure afterwards.
No. This is what we're doing in reality, but we're setting up a test.
We have never done anything currently. Right now, we are just comparing ideas.
Yeah. We're trying to get a grasp of what's going to happen, right?
What should or shouldn't happen on a sphere. We can agree on that. It doesn't matter.
I don't know. You tell us what you imagine happens in reality, and I'll tell you what I imagine happens in reality,
I'm not talking
right?
about what happens in reality. I'm talking about what would happen if we live on a sphere.
Oh, right. So you don't consider that reality then? You just just an imagined thing, right?
But that's besides the point in this discussion.
What do you mean it's besides the point?
It's besides the point because we are discussing just the concept of measuring stuff on
vertical and horizontal are reality positions, right? They are what can you say? They are like they're not on pieces of paper. You can't imagine them. You have to be able to experience them. Let's say they are empirical, right? Vertical and horizontal are described geometrically.
You should see. But how would you know what you're gonna look for if you don't even have an idea of what you're gonna look for?
You're gonna
You have to have an idea of what you're gonna measure before.
That's what we're doing now, right?
Yeah, right.
So if we can get a tool,
it has nothing to do.
In reality,
Listen to me. It has nothing to do with what is reality or not currently. Reality we can derive from the measurements later. Currently, we are discussing what the idea of actually what we would observe.
Yeah.
if the Earth is a sphere,
And you
right?
you seem really upset about me talking about reality.
No,
What's up with
no,
you?
because it seems like you're conflating reality and the idea conceptualization of a sphere.
I'm just like I live in reality, and I'm sorry about this, but
I know
this
you
is
live in
this is
reality, but
what
you have a
I
brain
do.
that
My
you can
brain,
think, right?
my brain doesn't accept imagination, right? I can tell you what we can do in reality, right? There are tools to establish horizontal. Now, we can talk about, if you want, no, wait a minute. There's tools in reality that establish horizontal. Now, and we also have tools called levels, water levels. There are tools, right, that establish horizontal. Now, we can talk about what the tools do and how the tools actually work. But you guys don't want to do about that. We want to talk about the metaphysics behind the geometry, right?
We're discussing
yes, we are. We're discussing the geometry, yes. And we are saying that, right, it has to be based around vertical and horizontal, because they are the reality of what we are actually going to be using when we come to measure this reality, right? So we better base our whole understanding and what we're doing around understanding vertical and horizontal and the relationship within geometry that they are considered perpendicular and straight lines in Euclidean geometry. Now, you want to bring another geometry, right? Please don't just state things and go fight the flat earth geometry on us. Give us some definitions, please, of what you're going to be using as your framework.
Haven't I given you answers on all the questions you asked?
You had straight lines and triangles, so you're having straight lines still, but you're just imagining them curving.
Oh.
Yes.
So my point with this argument here, which I pointed out now, was that I could tell you how I would expect my tool and my measurements to look like if you lived on an Earth shaped like a toilet roll. I can tell you how that would look like. And I guess you can also imagine how it would look like. You can conceptualize that shape in your head and figure out how that would look like.
I have a fundamental understanding of the physics of water, right, and what water does, so
I don't care.
It sounds ridiculous. I know you don't care about. You just make shit up.
I don't care about reality. No, I don't. How do you think you do this kind of measurement? Do you just do the measurement willy-nilly without knowing what you're looking for? You have to know what you're gonna see before you actually...
What measurements have you ever taken, please, Funk?
In relation to the shape of the Earth, I haven't done any precise measurement.
Okay. Do you know any... have you studied anything to do with either geometry and let's call it surveying?
Yes, I got not surveying.
Not surveying, just geometry.
Geometry. I haven't gone to geometry school, but I have.
So you've got no geometry, no surveying, and you've never took any measurements, yet you're here. What are you doing here, exactly? Defending Fight the Flat Earth geometry.
I haven't done a geometry course specifically. I don't know what that is. I have taken a lot of math in college. I've taken a lot of math in school. Some of it was also geometry, yes, but most of geometry was finished in high school. So.
Okay. Can you ever remember being taught that straight lines can curve?
I know that those are just a definition. So if you want to change the definition, you can do that if you want to.
Sorry. You can change the
Sorry.
definition of a straight line.
You're just talking about definitions now.
Yeah, of a straight line. You
redefine something. You can do that.
Okay, so you're of the opinion that you can just redefine the definition of a straight line.
As long as you apply it as what it is, as what it is defined as, then no problem.
Okay, so you are going along with, I'm calling that fight the flat earth geometry. People who can just have a fundamental redefinition of a basic fundamental first principle sort of thing, right?
Oh, it's just a language, so you understand what you're talking about.
Yeah.
If I use a
Can I
word, you have
redefine
to
my Ford Mondeo? Can I redefine that to a Ferrari?
Lamborghini.
It's a definition of you're using a definition of a word.
Well,
it's not something you're in
dude,
relation to reality.
We're talking about here, right? The curvature of the thing we think we live on, right? That you think you live on,
that.
right? But if you say you can just redefine straight into a curve, then how do we know what we're meant to be measuring? How do you do that? How do you justify that?
People have a definition of what level is, and definition of what horizontal means, and definition of what vertical means.
Yeah, they think it's straight, but if you just go, well, we define straight as being a curve, so well done, you can have that straight thing.
What the hell are you talking about? Level is perpendicular to plumb line, right? If that plumb line is not parallel to each other, then it curves. That's how it is.
Definition 10. Euclidean geometry.
It doesn't
when a straight line standing on another straight line makes the adjacent angles equal to one another, each of the angles is called a right angle, and the straight line which stands on the other is called perpendicular to it. So the very definition of perpendicular states two straight lines. Okay. So have you got a definition from your made-up geometry that you've just made up right now to defend Fight the Flat Earth, where you can have a definition of an angle to a curve? Otherwise, we'll take it as though when you say perpendicular, you mean two straight lines.
Create a tangent on that curve, and at that tangent, you can create a perpendicular.
Yeah, that tangent point that you talk about is the point where it is horizontal. So there is no difference. I'll keep saying this again. Your perpendicular is perpendicular from both ends of the same line, even on your ridiculous model of your geometry. The words you're saying coming out your mouth, they're straight lines, dude. Imagined circle. That's all you've got.
You have talked about this without actually mentioning anything about reality at all now, currently.
Me? Vertical and horizontal, that's all they are, mate. They are reality measurements.
No.
That's all we're talking about.
You have defined it as something. You haven't measured shit currently.
Says the person that admittedly not measured shit or knows shit about it.
We're talking about what vertical, horizontal, level and curved means. The meaning of the words.
Yeah, with a fundamental understanding of surveying and geometry.
That's what I'm talking about. Yes, but you haven't even started talking about the fucking measurements. You're talking about the definition of horizontal, vertical,
because
curved, and level.
You think straight lines curve.
You're done. You're defining the fucking word.
Yeah, you think straight lines curve, right?
It doesn't fucking matter. It doesn't fucking matter. You can make up your own fucking
It doesn't
word.
matter. Semantics.
Funk, keep an eye in your language, mate. Bev's not swearing
Okay,
at you.
sorry.
There's no need to
Sorry.
swear at Bev.
I don't mean to swear at him. I'm just swearing.
Yeah,
in
getting
general.
triggered, right?
Yeah, he is, isn't he?
Oh, but it's going around in circles, so I find it
No,
kind of pointless.
no, straight lines, mate. Straight lines. I'm making a brew. I'll be back in a minute. So somebody
I wish
keep him
it was
happy.
straight, so it went in one path. It doesn't. It goes around in circles. So I don't know. I have had this discussion with you. I remember one time you went on for 5 fucking hours. Sorry, again.
Language.
You went on for 5. You went on for 5 hours one time, and it was quite boring. Eventually, everybody just said, "We don't care. You won," and you just left. I think this will happen here as well.
Yeah, well, if you refuse to accept the truth about geometry, then you know you're gonna get a bit.
It's just definitions. It's just a dictionary.
Words have definitions to give them meaning.
Yes, and he is changing the definition from what
No,
I mean.
he's not.
I mean
You
its
are
meaning.
changing the definitions.
Did he say I won last time and everybody gave up
what?
and said that I won?
So what? So what if I change?
That's what he said.
So what if I change the definition? So what?
Words have definitions to give them meaning. And you want to change the definitions, so therefore you want to change the meaning of the words.
Yes.
It doesn't work like that.
Why not? You can change the dictionary all you want. I mean, as long as he understands what I'm talking about, it doesn't matter.
Yeah,
does
but
if he uses my dictionary, if I have my own
change
dictionary,
the definition of established words to suit your narrative, and it doesn't work like that.
You think I do, yeah, I know you think I do that. I don't think I
No,
am doing
that is exactly what
you
you're
are
doing.
doing that.
That
But
is
then you understand my issue
we
with
are
what
using the
this discussion
established
is.
we are using the established definitions of the words, and you want to come along and change them. Like Bev is using straight line as straight line. Now you want to come along and curve the straight line. That is ridiculous.
Yeah, it's just a definition in the dictionary. I know
The
that.
definition of a straight line is uncurving, and you want to come along and curve that straight line.
No, I am not
Don't
saying that.
be silly.
I'm saying level can be curved line.
No, level cannot be a curved line. Level is a horizontal plane.
Pointless discussion to have.
Level is a horizontal plane.
I know you say that, but it doesn't make it reality just by saying that.
I'll tell you what, right?
Measurement doesn't show it, so it doesn't matter what you're saying.
What happens if you've got a 3,000-mile long level on the Earth? What happens?
What kind of level?
Well, just a long straight edge. A long spirit level, say.
Oh, spirit level?
Yeah.
Well, the center of the spirit level will be level. On the sides, it won't be level anymore.
And the two ends, what happens with the two ends? What happens with the two ends of the spirit level in relation to the surface of the Earth?
They're sticking up in the air.
Exactly. So that level is a straight line.
Yeah, spirit level is a straight line. Yeah,
it's a straight line. Well done.
Yeah, but it's a straight spirit level. So what do you expect, right? That's ridiculous.
Spirit level gives
you
a straight line.
It's meant to do that, but that's why spirit levels are meant to measure level over inside houses.
Has anyone talked to him about the water level yet?
Why do you think a spirit level is? Why do you think you're not using a 10-mile long spirit level?
Funk. Have you ever heard of a water level?
Yes.
Yeah, the tool, a water level.
Spirit level now.
But we are talking about a. Really, we're talking about an auto level, which is like a telescopic sighted level, and a water level, right? We're talking about comparing the two of those practical tools.
Yeah, why not using a auto level, only an auto level?
Well, first of all, that's what we would do to establish a horizontal over 3 points over a mile, right? Start, middle, end. Establish a horizontal.
Yeah.
Do you think that's possible?
And they are not.
Do
they are
you
not
think?
measuring-
Do you think that is possible, that a surveyor could lay out 3 points on a horizontal line? All 3 points on the same horizontal. Do you think it's possible?
You could draw a straight line, yeah. Does not
No,
have to be
a
horizontal.
surveyor to lay out a horizontal line of 3 points over a mile. One at the beginning, one at the midpoint, half mile, and one at the end point, 1 mile.
Oh,
3
you mean like
points.
that? No.
A, B, C. Horizontal line all the way across those 3 points.
All
Do you
those
think
three
it's possible?
all those 3 points will not be at the same angle. So
Do
no.
you think it is possible that a surveyor, a professional on Earth, right? It's a job, it's a profession. Do you think it's possible for them to lay out 3 points of a mile, one at half mile, one at the full mile, one at the beginning, then 3 points in a horizontal line? Do you think it's possible?
You're talking about the straight line now? Are you talking about the straight line?
I am talking about a horizontal line, which I don't know about you. Do you think that's straight? Or do you have bendizontal?
The horizontal line is not horizontal at each point. Just
oh my
it can be
god!
defined as horizontal.
A horizontal isn't horizontal. What are you talking about, Funk?
Horizontal.
Are you the best that they've got? Kosho, you called this guy in, did
no,
you?
he didn't call me in.
Oh.
Jesus Christ.
Well, why did you come in then? Because you're not really doing very well for anyone.
I think I'm doing actually, but you are one of the most ridiculous discussions I've ever had with, because all you're doing is opening up a dictionary and telling me.
No, I'm
this is what the
asking
dictionary
you
says.
if you
Now,
think
this is
it is
reality.
possible for a surveyor whose job it is to lay out elevations and all of that sort of stuff, plot lands and lines
No,
and points and stuff. I'm asking you if you think it's possible that they could lay out 3 points over a mile on the same horizontal, right? It's very simple, geometrically as well. Very simple. Can a surveyor, professional person, lay out 3 points on a horizontal plane? Do you think it is possible?
Horizontal at each spot would be different. It's not they wouldn't be the same angle in relation to each other, but they could be at different elevation and hit the different points. Yes.
Can you just restate that
Do you
again? I think it
understand
got a
what
bit
you
muffled.
said?
No, go on, please recap.
Recap. I cannot recap something which was already very short. So what I said was these 3 points. You can have a line pointing through all 3 of them. But
straight
at
line?
each measurement point.
A straight line.
Straight line. Now you're using straight.
Yeah, horizontal.
Can you make a straight line?
Yeah, because horizontal is a straight line, isn't it? A horizontal is a straight line, isn't it?
Excuse me. Horizontals are straight line, but straight lines are not necessarily horizontal. And I asked you, can it be a straight line? And you said no. And I
Horizontal
said, yes,
is a straight line.
I agree to that.
Okay. So that's what I asked you about the surveyors laying out a horizontal line.
No.
3 points on a horizontal. A horizontal is a straight line.
Oh my god. So these 3 points will not have the same horizontal. So no, they will not pass through each other.
Okay, so
They will
you're
not be
going with
parallel.
it's not possible for surveyors to lay out 3 points on a horizontal line. Now, can you just give us an idea on why you say that?
Because they are angled differently in relation to each other. I think I've actually said this 20 times now. I cut the crap and get to the point, because you have asked me the same questions.
Okay, yeah, you've just said again that horizontals
Again,
are
yes,
at different
I said it
angles.
again.
What do you measure that angle from and to,
In
please?
relation to?
Yeah.
You're leveling each spot. You're leveling in relation to gravity.
Okay,
And,
so you're measuring an angle between a horizontal and a horizontal, are you?
well, local horizontal, I would use that word.
Yeah.
Instead.
So where would you measure the angle? Locally?
No,
Between the two horizontals locally, or
relative to.
Yeah, at which point though?
It's a relationship between the two.
Yeah,
The
and
angle
like
between the two.
an angle is the inclination of
It's
two straight lines to each other, and you've got a horizontal and a horizontal that meet at a vertex point, because that's where you measure your angle from. So you've got a horizontal meeting a horizontal at the point that you want to measure the angle, right? And that's where you want to measure the angle between the horizontal and the horizontal at that point where they meet.
No, you're measuring the you're measuring the angle between. It doesn't matter. You see, let me explain something now. The horizontal line, just because you create a fictitious horizontal line from each measuring point.
But it's an auto level. It's like it's got crosshairs,
yes,
right? It's
I
not
know you're
fictional.
saying that.
You
I know
can
you're
look
saying
through
that.
it.
But if you take that horizontal line
Yeah.
and you lower it down, it's eventually going to hit that equipment, right? And it's going to be at an angle. You don't have to measure. You're not measuring the angle at the point between them.
No, the tool
right?
establishes
It's
the horizontal, right?
It's the relationship between the two observation points.
The two horizontals.
I made a picture that might help you explain it.
Ah, right. So, okay, Kosho. So where do we measure the angle? Can you just point to where we measure the angle? Which angle is it that we're measuring? Because I think this may point out your little flaw that you have.
Yeah, but if you lower down the horizontal line, wherever they intersect, the angle will be the same. So it's not an angle which is specifically between them.
Okay.
It's an angle between the two observation points.
Yeah, it's an angle between two horizontals.
It has nothing to do with
So
where they intersect.
would you go to the middle and then measure the local horizontal there, and then the angle difference between the other two horizontals that are meeting it at that point?
What did I just tell you? I told you exactly the opposite. I just told you it does not matter. It has nothing to do with the point in the middle. It's just where it happened to intersect, right? Because the angle between them are the same, right? But whatever these horizontal lines, if you lower them down or put them higher, the intersection point is going to move, but the angle between them is always going to be the same. That's all you care about.
I'm going to have a go at
the observation point. Do you understand?
It's the angle between the observation point.
Yeah, it has nothing to do with the cross in the middle.
But that isn't that where the intersection, the angle difference?
It's a graphic.
So where draw where the angle is that we're measuring, please. Which angle are we measuring?
The angle between the first and the second observation point. I don't know how else I can say.
That would be the cross
The horizontals, yeah, yeah.
Yeah, it looks like it's in the cross in the middle, but it happened to be there. But it's just a, what you call it, it's a helping line, you could say.
It's a what?
But whatever
hang on a minute, hang on. You said that cross in the middle has nothing to do with the angle between the two observation points, and now you're saying that it is exactly that cross in the middle that is the angle between the two observation points.
Yeah, it's a visual illustration of what the angle is. Yeah.
But that angle will always be formed by that cross.
Yeah, but what happens if you lower down the local?
So you've just completely contradicted yourself.
If you lower down the horizontal, if you lower down or put it higher, if you're at a higher elevation,
then that cross will always form the intersection angle that you're looking for.
Yeah, but not in the same place.
So why are
if
you contradicting yourself?
If you're moving the locally horizontal on the left side, if you move it higher up, where is the cross going to be then?
It will still be
Not
formed
in the
by the
middle.
intersection point of those two lines, which is formed by that cross that we are talking about.
Yes, but it has nothing to do with the point that it is a...
But we are not talking
magical
about the
place
point
where the
where
angle
they
is
are
happening.
crossing. We are talking about the cross that is formed by the intersection of the two lines.
Yeah, I know that. That's just a visual representation of what the angle is. But it's an angle which is a relationship between the first and the second observation point. And it has nothing to do that the cross is in the middle.
Nobody ever said it was. The only
It
person
sounded
that
like
has said
Bev
that is
said
you.
it.
No, the only person that has said that is you.
Okay, I misunderstood you. It sounded like you said that earlier. But I misunderstood. So then you understand me then. That's fine. We can continue.
I think the only person that misunderstood you was you.
How can I misunderstand myself?
Because you're...
How can I misunderstand myself?
Because we were saying that intersection point gives you the angle between your two horizontals that you were looking for.
Yeah, that's
and then
it.
you said, no,
Full
no,
stop.
that intersection point is nothing to do with it, and you went off on a tangent about that intersection point. You misunderstood yourself.
Yeah, I've drawn a thing.
No, it's fine. I
There you go. Yeah. See, look, I've put a vertical and a horizontal at the intersection point, and I've marked right angles there, so you know that is perpendicular. So that would be the vertical at that intersection point, and that would be your horizontal at that intersection point. Now, where would we measure the angle? Can you show us which angle we're measuring?
I was right.
Yeah, which angle are we measuring there, please?
I was literally right.
Can you
so
just take that now and mark angle A and B, because we need to check both sides. So put A and B and the position of the angle where we're measuring it, please.
Funk, I drew a new picture for you.
Yeah, so if you move up... yeah, thank you.
Right.
This angle...
What's that? What's that measuring that angle up there? What is it?
Well, how the fuck do you get up there to
yeah.
that angle?
No, this is we're being serious here. I know you don't know anything about surveying or geometry, right? But how do you measure that angle, please?
Oh my
Kosho.
God. Seriously,
Kosho.
Is that what you're talking about?
Yeah. And is that the triangle you're making? Would that be that bottom bit is a 90, and then that little bit right in the centre angle? Is that your other angle that you're making? And
are you using your drawing as a...
are you go on? You use Kosho's angle there. Go on. I dare you. I dare you. Use Kosho's angle to show us how to measure this angle of divergence of the horizontal, please, by using that angle there that Kosho's give you?
Are you talking about?
I think it's a challenge for you, really. I bet they're giggling, aren't they, in the back room there, Kosho, with that one.
Bev, if you want an explanation, you need to be quiet a little bit. So, are you talking about it? I would just want an explanation from you. In that drawing you made, Bev,
yeah,
you made a cross in the middle, and you said horizontal at that point.
I said that is vertical and horizontal, because I marked them. Like, that is the vertical position is right in the middle of the thing, right? And 90 degrees to that is the other line that goes across the page.
I know your brain is stuck in this idea, but I want you to think a little bit different now.
No.
In this local horizontal...
No, wait a minute, Funk. Before you carry on spouting your bullshit. You've got 2 lines wrote on there that say local horizontal. What I thought I'd do for you was just to give you an idea that line in the middle is vertical, right, in relation to the TV screen that you're looking at. That is an actual vertical, a very good representation of a vertical line. And because, can you see the little right angle marks that I've put there all the way round? All 4 of them are equal. That means that other line that is right angles to it is a horizontal. Okay?
Bev.
Yeah, a real horizontal.
Can you let me please ask you a question about this drawing now? Okay?
Hang on. You haven't answered me yet as to how you get up there to
I don't
measure...
remember. Bev, have talked for 5 minutes. Sorry.
How you get up there to measure that angle that Kosho's just drawn in there?
You're meaning practically measuring it.
Yeah.
The bottom diagram, the one that Kosho put in the chat.
You're talking about practically measuring it.
I asked you how you measure that angle.
You're talking about a practical measurement.
I asked you
in real
how
life.
you measure that angle.
Or I can calculate it for you if you want to.
No.
Or are you talking about
said
practical
measure.
measurement? You can say.
Measure.
Can you say yes or no? Do you mean
I
practical
want to know how
like a
you
theodolite?
measure that angle.
With a theodolite, for example, you're talking about.
A theodolite would give you that measured angle.
I could do, yeah.
But how does the theodolite plot that point in space?
What are you saying now?
How does the theodolite plot that point in space to give you the angle to measure at?
Oh, if you know the distance to the object in the second observation, and you're pointing your instrument level, and then if it's at the same elevation, it should hit it dead on. It should not hit above it.
Well, what can you give us an idea why Kosho might have give you a drawing with that little thing in it there, that far up, that angle? Do you reckon I think it's a challenge for you, really.
You mean the angle in the top right corner?
Yeah.
What the relationship between that? Yeah, it's a right angle, so you can calculate the. If you know that angle and one of the lengths, you can calculate the angle between the other local horizontal.
Which is a right angle? Did you say?
You can create. He created a right angle.
Where?
Can you not see it on the right?
No, it's like. Can you see the way I've drawn the little right angle marks on the ones when I drew it, so you could tell what was a right angle. I did that specifically because I know that Kosho doesn't do anything like that because he doesn't
like labeling drawings, does he, Kosho?
Where is your right angle, Bev?
Mine.
Right
I've got four of them right in the middle of the vertical and the horizontal. Can you not see them?
Yes.
Okay.
I know what you mean.
So now we're talking about Kosho's drawing that you said.
Are better because Kosho's are in relation to the vertical line, and yours have to
Where's the vertical line? Where's the vertical line? Does he mention it?
One each on each side.
Which one's that? On Kosho's.
But I am going to.
Can you? No, wait a minute. You're just going to try and get out of this now. Where's the vertical, please?
No, seriously.
Where's the vertical, please, on the Kosho's drawing?
Vertical line on the right side. It's the vertical line.
Where?
There are no verticals on there.
The one that goes.
That's just a line.
The one that goes up in the that's go up in the right corner.
It's not vertical. Though, is it?
That's just a line, isn't it?
You tilt your screen to the left, and if that's what you want it to be vertical.
Yeah, that's not even a right angle to horizontal, is it? The one, your imagined local horizontal that isn't even horizontal. I mean, that right vertical angle isn't even a right angle to that presupposed one that you've labelled horizontal that isn't horizontal. So you know you've got a vertical that isn't vertical and also isn't right angles to the one that's labelled locally horizontal that isn't even horizontal. I mean, your geometry's doing fantastic, and Kosho has given you a drawing with a little angle marked in the top right hand corner and gone, tell him how we do that. Off you go.
The angle in the top right hand corner that you can't even get up there.
I want to do an explanation on your drawing, Bev, before you guys continue.
It's like Kosho's just dropped you in it and gone like, yeah, Funk, look, here's a picture. Explain this bullshit.
Bev. Bev.
Yeah,
Bev,
go on.
Funk,
can you hear
funny.
me?
Yeah, I know. You're trying to escape. We'll give you this out road for a bit, because
I know you guys made your own idea of what's going on now, but literally all you're doing is talking over me. I haven't said anything.
It's funny though. It's funny. Kosho's dropped you in it. You don't even know yet.
I don't know. You find it funny. I might as well not be here because I'm not really part of any.
Well, yeah, you already admitted you don't know anything about surveying or geometry, and you've never took a measurement in your life. So all of this is just imagined.
When did I say I didn't understand anything about geometry? I
Well,
probably have more education than you, Bev. I don't know.
Oh, really? Nice. There we go. But so you...
It's not an atom. It's not an atom. What's the atom about that?
Yeah, it is. You think you're better than Bev.
Why is being more educated?
You are assuming.
Why do you consider?
You are assuming you are more educated than Bev. You are making an assumption.
Well, it's an assumption because I have a master's degree and not everybody have that.
Oh, a master's degree in what? What's that in?
Do you have that?
What's your master's degree in? Funk?
Engineering.
Civil engineering. No way.
Engineering.
No way.
Engineering.
Smart guy. Hey,
Funk,
before you continue,
I said engineering, Bev. Oh my god. Yeah, thank you. And literally, you have to put it into a teaspoon into the mouth for them to
That's not vertical.
Do not.
Though, is it?
Yes,
Kosho?
it is. Oh my god.
No,
That's a vertical.
You've got to labelled it now.
If you do not understand that that's a vertical,
line is
then
not vertical.
Locally, it's local. That's what a local vertical looks like.
Well, my god, do you know what? It's a good job you're not doing civil engineering.
For everybody else on Earth, this is vertical. So if you don't understand vertical,
you've got a master's in civil engineering. Did you say a master's degree?
Just engineering, Bev, not civil. Thank
God.
No.
Oh right.
I never said
that.
Because
if he was building bridges,
listen to me. You guys put that in yourself.
No, you said it. I asked you what your master's was in.
Go back if you recorded me. Go back and listen to what I said. I said engineering. That's all I said.
I said that. Did I not say that just now, Bev? That his master's degree is in engineering, not civil engineering.
Okay.
I said that. Okay. Bev is hearing.
I'm saying, I'm sorry. I heard civil engineering. What sort of engineering then?
Yeah. And if you had
what sort of engineering then?
I said at least 10 times.
Engineering.
Yeah, what sort of engineering?
I said no, not civil engineering.
Yes.
Engineering.
And I've said quite a few times.
I reckon he does.
You had actually
listened,
listened, Bev, you might
he engineers
as well actually
those
hear what I
pop-up
said.
birthday cards, Bev.
Yeah.
You know, the ones where,
I don't think you hear what I
they
say, Bev.
pop
Okay.
up.
That's the problem.
So what
So,
engineering,
Bev,
please? Please.
Are you
What
ready?
what type
Are
of
you ready
engineering
for-
do you mainly do?
I'm an electrical and automotive engineer.
Okay, so you vertical and horizontal should be, I don't know, like you must have experienced them in reality.
What's your credentials, Bev?
Pardon?
What's your credentials, Bev?
I've
On
got
this
I have
subject,
a
a lot
yeah.
more than yours.
I have a
Oh,
I have a
what's
qualification in land surveying. Okay, so is that okay for you or?
Land surveying is
Yes.
fine.
Yeah.
Is that more of a... Do you need a degree for that, or is it just a...
No, it's just a like qualification in land surveying, right? Because you said you know nothing about it, and you've never done it. Well,
I said I know...
I
don't
have
know
a
lot
qualification
about
in it, right? So, I mean, I wouldn't presume to start telling you that because I've done a little bit of electrics, that I know more than you about electrics, right? That would be silly of me, wouldn't it? That would be absolutely ridiculous for me to
But-
come and try and do that.
Yeah,
Bev,
but
you
that's
should
why...
just play
That's why
constantly
I'm...
what you don't know.
But this is nothing. This has nothing to do with surveying to do. That's why I said, "Is this?
What,
Are you talking
horizontal
about
and vertical has
practically-
nothing to do with surveying, measuring the
can I-
land.
Yeah.
Can I just confirm with him that those drawings that have been popped in the chat have nothing to do with surveying?
Mm.
No, you can understand it without understanding surveying.
So you're saying that those drawings that have been put in the chat have nothing to do with surveying?
Hmm.
And the
No,
question that Bev asked you about levelling a horizontal plane over the course of a mile has nothing to do with surveying. Is this what you're saying?
Leveling, using a level has nothing to do with surveying.
But Bev was talking about levelling 3 points, one at half a mile and one at a mile. And you're saying this has nothing to do with surveying.
That has more to do with surveying. Yeah.
Well, this is what we're talking about. This is where
I
those
know.
diagrams in the chat led to.
Yeah, you see,
And
like
you
one of
now
them.
claim,
Yeah, one of
you
them
now
would be
claim that this
one
has
end.
nothing to do with surveying.
Yeah, like you've got a local horizontal at one end of a mile. That's one of your
Oh.
points. The halfway point would be, where that little cross is supposed meant to be.
Yeah.
And the other point would be the other end that it says local horizontal, right? So now you've got a reference frame of what you thought the horizontal was, right? And now you can plot those points on
I
that
wouldn't
picture.
expect those horizontals to be the same in the first place, so I don't know what you're talking about.
What about if we did it, because if we're doing it over a mile and we are using 2 end points and a center point, would you not suppose that the 2 horizontals on your model that you're imagining would meet in the middle?
They would. They could meet in the middle depending on
Right, so
the
that
elevation of
that
the
would
center.
be where your high spot is there, where your 2 horizontals meet at the high spot
High-
in the middle
spot
of the
doesn't
2
mean that.
bits, right?
It doesn't mean high spot. Doesn't mean anything. Like
What? Well, it's not, they're not going downwards, are they? They're going
they're
upwards, aren't they?
level. No, they're going level.
No. The level is on a horizontal plane. Those
No,
2
they're not going up.
horizontals.
They're going level, and the one in the center is meeting them from both angles. At an angle between them.
An angle between the 2 horizontals. Yeah.
Yes.
And so the measurement like if we go back to the other bit. Yeah. So would the measurement be taken from a local horizontal, like I pictured earlier,
But
to the other 2 horizontals that are meant to be meeting it? Or would you just measure the angle between the
mind.
2 horizontals where they intersect?
Bev, if you don't mind, I might add something new to the discussion rather than talking about levels.
What about some sort of an explanation as
Oh
to
my
what the
God,
fuck
Bev.
you're talking
Bev,
about?
I had tried to ask you about your fucking drawing for 20 minutes now. Can I please ask you a question?
My drawing?
Yes. You
That
actually
was
listened.
Kosho's
Thank
drawing.
you.
That's
Bev.
Kosho's drawing, right?
No,
That one.
It's,
Or
it's,
one. Did I do one?
It's 15 minutes back because you have been talking so much now, Bev.
Did I
I'm
do a
trying to
drawing?
ask you- Yes, you
That
might not
you
remember
edited my drawing.
because
You saw when you edited.
Oh,
How
I
fucking
put some
nuts.
lines on top of Kosho's drawing.
yeah.
Yeah, a vertical and a horizontal.
Thank
Yes.
you, Bev. You posted something 15 minutes ago.
Yes. An
So are you able to
actual
listen now and
vertical
be-
and an
Are you
actual
able
horizontal.
Are you able to shut up a little bit and let me speak now for about 2 minutes?
Go on, I've got it
without
on screen.
interrupting?
Off you go.
Thank you. So I expect you to be quiet now. That local horizontal line on the left side and that local point on the right side, they meet in the middle, forming a cross. If you measure the angle that they're at that intersection, that angle will be a certain degree. Let's say it's 2 degrees between them. If you lift that horizontal line up to another elevation, the one on the left side, that intersection point is going to be somewhere else. But the angle is going to be the same, isn't it? Bev.
Yeah. Well, yeah.
And
DP,
where
can
is
you
the
see that
horizontal
picture
line?
there, right? Can you see what he's talking about? He's talking about measuring the intersection and the angle where those 3 different horizontals meet. Right? That's the angle that he's after us
He's
measuring.
talking about, yeah, that cross point right in the centre, yeah?
Yeah, where all 3
Yes.
horizontals meet, right? Now, which one of those particular angles are we measuring? This is what I'm trying to want. This is the got to be the thumbnail for this one, right?
Between them. I understand what you mean now, but that
Yeah.
horizontal is still horizontal regardless of what
Yeah,
elevation it is.
which angle though, please?
The angle at the center cross.
At the centre. That 90-degree angle?
It's
The
not
one that I
90
marked in?
degrees at the center. No, I'm talking about the cross in Kosho's drawing.
Right, I'm going. Let me. I'll label it up. A, B, C.
The
I'll do
red-
that.
Yeah,
Red
do
dotted
that,
line
label it.
cross.
Right. Here we go. Right. So we've got that one. That one. That one. Ooh, that was a big one. That one. That one. That one.
There's no.
And
Oh.
that one. Right, so we'll call this one 1, 2, 3. This one is 4, 5, 6,
6 angles.
7, or 8. Right, copy. It's coming in the chat now, right? This one. This is what? Debate discussion.
Yeah.
Can you... Oh,
So I'm gonna ask you the same question.
right, here we
again,
go.
but with
I've labelled it up with all of the different angles there. You see that? 1, 2, 3, 4, 5, 6, 7, or
Yes.
8. Can you tell me which angle we are measuring in between the horizontals, please? Or are we going to add a
4.
few of them up together?
the 4 and the 5.
4 and the 5. So the angle between the horizontal, and the horizontal.
Yes.
Okay.
They aren't parallel, are they? So there's an angle.
Yeah. The angle between the horizontal and the horizontal.
Yeah.
Yeah.
You see that there's no.
You've
actually
You've
an
never
angle
actually
between them.
done any surveying or any measurement or anything like that, have you?
No, I haven't.
No. Have you ever actually had to do anything sort of practical problem solving sort of thing? I mean, Kosho likes that sort of stuff.
I do that every day. At
Okay.
Work, so, yeah.
So can you work out a test that we might possibly be able to do to work out how much this is being able to be done? Like, you know.
I've got a way of doing it, Bev. Right, your 2 observation points. Right, if you put a straight line between them, right, then you form a triangle, right, and the total number of angles in that triangle that you've just formed gives you the angle between the 2 observation points.
You make a straight line in between the 2 points, and that makes a triangle.
Points. Yeah, and the total number of angles in that triangle gives you the angle between the 2 observation points.
Okay, straight line.
Yeah.
Okay. What do you think about that, Funk? Does that sound good?
Sorry, just so I follow him correctly. You're drawing a straight line from the observer. A is on the left side, so observer A to observer B. That's what you're saying.
Yeah, draw a straight line between them,
okay.
which gives you a triangle.
Yeah.
Where 4 and 5, the combined angle of 4 and 5 are one angle, and then obviously the angle between your straight line and your 2 local horizon lines at your observer points. So that gives you 180 degrees in that triangle, which is the angle between your 2 observer points.
Yeah.
Yeah.
But what are they looking at? Are they looking at something in the middle?
No, because your 2 observer points are on a straight line.
Yeah. Yeah, I mean,
but
you see the way Kosho's even drawn that there. Are you having that? See, he's got the middle point higher. I mean, I know you say it isn't higher, but I mean, when you look at it, even way Kosho's drawn it, it's higher, right? Because it's higher up on the curve.
Yeah, but that's only from that point.
It's higher though, isn't it? It's higher than the other in relation to the other 2 on the outside. The one in the middle is higher.
Yeah, but if you move that camera over to the observation on the right side.
We added cameras in now.
Oh, just to put the center point of what you're looking at from another point of view.
I don't know. Wait a minute. You've put a camera in the middle.
They're going into Muppet vision.
What is on top anymore? What's on top? And suddenly the right.
Well, that one, like with that camera.
Right.
I don't know why you put a camera there.
The camera. Forget about the camera. Call it whatever you want to. Just make it.
Let's call it the midpoint of a mile-long water level. Yeah, would you go along with that? I mean, Kosho's even drawn it like it's a water level. Is that what you were trying to get at, Kosho?
I don't know.
If you have the memory of a fruit fly, I made this picture originally to give you an experiment to do. I've explained the whole thing to you. That's why it says water level and sight level. The water level is the blue line. The sight level are the 2 red lines.
Sight level.
You compare those 2, and that'll be your test.
You check that spot on. A sight level, that's what it is.
Actually, this is what he's trying to explain. The water level, if you're using
it's S-I-T-E, Kosho. Sight, as in like a building site. That's where they use them.
And website.
Yeah.
will only show low where in the middle of the water level. You draw a straight line between them. That's what he means by destroying.
Are you falling asleep, Funk?
Yeah.
You sound like you're talking into your pillow.
He had to go. You don't remember?
I'm using a headphone, so it might.
He's been. Have you been told to stick around because Kosho's struggling?
I don't think Kosho is struggling. I understood what you meant straight away.
No, Kosho seems to have opened a can of worms, chucked you in, and screwed the lid back on.
No.
Yeah, he did. That angle one was genius, Kosho. I mean, you must have been giggling away when you dropped that one on him.
It's ridiculous that you actually have to explain this. It's fine. I find it very ridiculous.
Especially the fact that you're certified.
Literally, I don't know.
Have you ever seen my water level? See the one that Kosho's done there?
You don't understand things I can explain to a 10-year-old.
Can you see the one that Kosho's done there, right? And he's got the middle bit up, right? Well, look at the bottom picture there, right? Well, that is an actual water level, right? With 3 points. Now, the green ones are meeting in the middle. There's like an individual middle point there. So that green one is basically what Kosho's got, right? But he didn't add the red ones in to check the level from the outside. But forget about that, right? Forget about that. Do you think it's scalable, that thing? Do you think it would be possible for us to make that water level a mile long?
You can make it a mile long, but it's not precise anymore.
With the water level, you think the water level wouldn't be precise if we made it like that, but a mile long? It wouldn't be level, would it not?
Because it will only show where level is in the middle.
Yeah. In the middle. Well, that's where it's got a bit in the middle, right?
Yeah, but that's the point of his drawing, Bev. Don't you understand what?
Yeah, and then that was the whole point of earlier when we were going over whether a surveyor could establish a horizontal line. You didn't seem to think that they could.
I said they could, but it's a local horizontal at that point.
Yeah, so would it be locally horizontal like the water level tool would be locally horizontal?
Are you talking about the spirit level?
No, I'm talking about the water level that you're just looking at, and you've just said over a mile. Yeah, the very same one.
The water level is using the pressure, the differential pressure on each side to establish what pressure is.
Okay. Yeah, so it would still be a water level tool, though, wouldn't it?
Yes, it is a water level tool.
Right. Okay. So, and it doesn't work. Doesn't work the same as an auto level, does it? Because an auto level establishes a horizontal line of sight.
It's a level line.
It's a horizontal line of sight. An auto level. Yeah.
Yeah.
Yeah. So that's different.
At that point.
It's local at what point?
It's level at that point.
Which point?
At that point, you have the fucking instruments.
Yeah, but I'm looking through a scope at some crosshairs. Are you telling me the point where I'm looking at in the distance isn't level?
It depends. It depends.
Because I'm looking through crosshairs. You understand what the crosshairs of an auto level surveying tool do, right?
Yeah.
Yeah.
Yes.
But you're saying it's not horizontal, right?
But you calibrated it. You calibrated it at that level, at that point, right?
No, they calibrated it at the shop. I just set it up and look through it.
Yeah, but it's odd. How do you know it's level? That it's showing a level line or not?
Because it's been calibrated. It's got a sticker on it, right?
Yeah, but when you turn it on, do you not understand?
Turn it on.
The equipment is working.
Yeah.
You just switched it
I've not found the on-off switch yet. I've never actually got it switched on.
Yeah,
I can look through it though.
What does it do when you turn it on? Does it have to do something inside?
Hey, secret. You're not allowed to know. You are not. I'm not telling you. I'm not telling you. It's a secret. It's a secret.
What noise does it make when you turn it on, Bev?
No, I'm literally asking you.
It's like a lightsaber. I can't tell you. I can't tell you.
I think I know actually a little bit more about this equipment.
I think it sounds like you do. It sounds like you do. You should make a video about this.
Absolutely.
I have actually studied this kind of thing.
Oh, okay.
It sounds like it. It sounds like it.
Where do you put the batteries, or do you plug it into the mains and charge it up?
You get a big battery pack.
Is it
You
about
guys talking about water level?
If I start
Switching the water level on. Yeah, that's
Funk,
definitely.
it's
We're talking about the water
know.
Funk, it's
level.
important. I know they're trying to
I can
confuse. They're
only
trying to
hear
confuse
Bev,
you,
Coach.
Funk. They're just talking about a tube filled with water. That's what they're talking about.
Go show.
They're talking about, yeah, I know that they're talking about the water level, but the auto level is something else.
Okay. Well, I thought they were asking you about where do you put the batteries
I don't
in the
know.
water level.
I think
Come in for your mate there, Coach Show. Come in for your mate.
You guys are being purposely confusing for some reason. Just like explaining what you're getting at.
No.
I know.
Okay,
but, like,
let me get this out. I don't talk that much.
I don't know
I'm
why
going
I'm
to-
still here, because I have literally one other time there was this discussion with Bev, and he literally just read from a dictionary for 5 hours.
Yeah. That's what we're doing.
People
So,
eventually.
I don't talk that much. I don't talk that much, but I'm going to tell you like this. If you already knew what he was talking about, what kind of instrument he has, you would know what's going on.
Yes.
Carry on.
I know what's going on, but he is talking about something else.
No.
Was I confusing you, dude?
No, I understand what you mean, but you're confusing yourself.
Okay, no, tell me what he's talking about, please.
Okay, the first thing, he doesn't understand that a
No.
local level.
Just okay. Tell me about the machine that he has that you can tell me about, please.
Okay, I think the way it has a accelerometer inside it, and I believe there is also something which is I believe it's rotating inside it to make it stabilizing, to create a horizontal line, level line, if you want to call it.
So the machine creates the horizontal line. That's what you're saying. That's what you're saying.
Yeah, it's self-calibrating at that point.
All right.
So if you don't have set it, if you haven't set the legs on it perfectly level, it will adjust itself.
Okay. So have you seen the machine that Bev is going to be rocking with?
I don't know what machine he's going to be rocking with.
All right, so how you describing something you don't even know what it is?
It's a general principle of how this works.
It's not general principle. How many different machines do you know that establish a horizontal plane or a local level at that one spot? You take that one machine. How many machines do you know? Have you seen? Can you post them, please? Or are you gonna Google it?
I'm on my phone, so I would rather not start searching for things like
Okay,
that.
that's fine. But okay, can you name the machines?
I'm not on the top of my head now.
I've put one in the debate discussion chat. There's no need for you to call up the company and harass the women that work there, asking them that if they think that the Earth's flat. Because somebody sold an auto level to somebody, right? There's no need for that.
Bev, have you tried
Shout
that
out to who was it?
John.
Bev.
John Rawlinson.
Have you called them and told them that the Earth is flat before?
Have I? Sorry?
Have you called that company?
No, what the story is, what I said was, when I got this level, I bought it. You see, it's got a sticker on it. That's the calibration sticker. And the calibrated guys, I made sure to ask them whether they calibrated it to make sure that it was, the line of sight was horizontal, right? I came back and said, yeah, the calibration guy said that it's 100% confirmed that this is an auto level and it's been calibrated to be horizontal line of sight. John then took John then took the ESS thing, a website, and called them up and thought, because somebody had said that level is horizontal, that he just conflated that, like Fight the Flat Earth says. That means flat Earth, right? If level is horizontal, that means to a lot of people that the Earth is flat. They conflate the two. Level being horizontal and the Earth being flat. So when I said that this level is a tool for establishing a horizontal line of sight, and it had been confirmed by the guys that calibrated the equipment, he then assumed that they told me that the Earth was flat. He then phoned their head office to make sure that the people that had sold this level to me had said that the Earth was flat. He was trying to get the people that sold the level to me in trouble for saying that level was horizontal. Now that's pretty dangerous, do you not think?
I think this whole it's like a clown house. This whole thing, Bev. It's nothing serious about it.
So,
It's a
whoa.
tiny world in here, and it's just ridiculous, the whole thing.
But yeah. You're here. Why?
It's entertainment.
So,
And John
entertainment.
Rawlinson was the clown that started all the rubbish off. Who phones up a company because they've seen a company sticker in a tweet on Twitter? Who does that?
Are you asking Bev?
No, I'm asking you.
What the hell are you talking about? Why are you asking me that?
Because
Say it again, DP. Say it again, DP. You didn't hear it.
This John Rawlinson, did you not listen to a word that Bev said? No?
Yeah, I listened to it.
This John Rawlinson phones up the company that have got the sticker on the side of the machine that Bev has brought. So this clown, John Rawlinson, phones them up and tries to get them into trouble. Because they've told Bev that they've calibrated the machine, and the machine is calibrated to horizontal. Now, you idiots have taken horizontal out of the frame of context that horizontal is used in, and you've twisted it to fit your own narrative. And this John Rawlinson has phoned this company and tried to make trouble.
So what did he do then? What happened when he called them?
The issue is not what happened, is that the issue is why did he do it in the first place?
Yeah, why is he conflating level being horizontal with flat Earth?
Everybody is. I think everybody understands what it actually means, except you guys.
What, level being horizontal?
Yes.
Yeah, an auto level is a tool.
Company have said it is calibrated to level being horizontal.
Okay.
I think he means you guys, as in like anyone who's not a ball defender.
Yeah, but we're not gonna get off that. Okay, give just a second. Funk. Regardless of me taking my money and buying a certified machine, and somebody come back and try to poo-poo on what I'm doing with the machine, it shouldn't even matter.
I agree, actually.
No, wait.
If you guys, they're
I
selling
wasn't done.
equipment.
Wasn't done. Is it okay?
Yeah.
Is it okay for somebody to call that machine company to try to get them in trouble?
I don't know what they can do about it, to be honest.
No. Listen, is it okay for another man to call the machine company to get information to poo-poo on the certification that Bev have got on this machine? Is it okay? That's like calling. It's almost like calling. I'm riding down the road, and I'm not going off into the weeds because we're gonna get back to it. It's just I'm going down the road, just because somebody didn't like me as a person, call my job. Is that cool?
Who's just said that he was calling them to get them in trouble?
Wait, Coach, shut up. I'm talking to him.
Bev's job?
No, I didn't. I was giving you I'm just giving you a scenario. You know what I mean?
Okay.
So is it cool that this gentleman called somebody else's job, try to get them in trouble because he certified the machine? Is that cool?
It depends on. No, I don't think like this. Let me get this straight. This Johnson guy or whoever you said, was it Johnson?
Doesn't
John
matter, it's
Rawlinson.
Rawlinson,
The
but yeah.
tweets are in
Is he a
the
calibrator?
thing.
Is he a equipment? He's a calibrator.
No.
Official calibrator.
No, outside
No,
guy.
he's a
It's a
troll.
simple question.
Okay, but the calibrator thought that does the person who calibrated the equipment think that the Earth is flat?
No.
Who
He's not even
cares?
looking at that.
Who cares? Yeah, that's not what the issue is.
What was the guy saying? Do you understand what they're talking
Yes,
about?
he confirmed. Let me say this,
You
right,
do
again.
not understand anything that's said
DP,
to
let
you.
me say this, right. The guy, when I bought the level, I bought it from the calibration office. I went to the calibration place, not the sales shop, not like Asda or Tesco or anything like that. I went to the calibration place, right?
Yeah.
And when I was waiting, I bought the level and they calibrated it on site. They took it away for 10 minutes to get it calibrated, right? So it was spot on. When they were calibrating it, I asked them, are you making sure that this level is horizontal with the calibration? And they said, yes. Yes. It's going to be the most accurate level you can have. More accurate than a laser level, more accurate than a theodolite. This is the most accurate. You'll be able to go within 1 millimeter on a 1 kilometer double run. Right? You will be within 1 millimeter of error. Now, I came back and said that. I just bought a level and posted a picture. And I said, yes, the calibration guys confirmed that this level will be 100% horizontal. And then John Rawlinson took that to mean that the guys had told me that the Earth was flat. He then took it upon himself to go and contact the head office of that particular firm and make a load of stories up about somebody on the internet had been and bought a level from that place and he'd been told that the Earth was flat because John completely mistook the fact that an auto level establishes a horizontal line of sight and mistaken that with the Earth being flat, which a lot of you people seem to do. You've done it a few times tonight.
I see they misunderstood that they thought that these people were saying that for some reason. This guy, I don't remember his name. And you're asking me, is it okay? And I would say no. First of all, they were wrong, probably. The person at the office, he did not. They weren't saying what he was thinking they were saying. And also, they took it at face value
hang on a
because
minute.
you posted something.
Hang on. The person at the office wasn't saying what you think he was saying. Can you quantify what you've just said there? 'Cause that was a load of word salad.
Sorry, okay, let me try to say it properly. The guy at the store you bought the equipment from, Johnson. I'm gonna call him Johnson. I don't
Rollinson, John Rollinson.
No. Wait a minute.
Rollinson.
I did no.
Oh,
Listen,
no.
I didn't buy it off him. I went to the calibration guys. So
yeah, that's what I'm saying.
So you're talking about the guys that
was
calibrate levels
I agree.
for surveyors all over this area.
I agree.
Okay.
I didn't say that.
Yeah,
You went to the
was
store,
my mistake.
to the calibration office.
Yeah.
And you bought it from the guy.
Yeah.
Right?
Yeah.
At the calibration office.
Yes.
And this Rollinson guy, he misunderstood. First of all, I don't think he has nothing to do with it. Of course, I don't know who the hell that guy is. Second of all, he took it at face value that what you said was correct in the first place. Right?
What, the guy said that he calibrated it so level was horizontal, that one?
No, that you represented it exactly like he said it, because it's like, it's very semantical, it's very, like you have to be, did he really mean what he said, you know?
Well, who?
Right?
Who did who really mean?
The guy at the calibration office, did he really mean what you...
Yeah, I asked him, like, I'm pretty definite when I ask people to confirm things, and I wouldn't say that he'd said it if he hadn't have said it.
No, I agree.
Right, because this is... You don't realise I've been doing this for a year, right? Do you not think I would take the chance to ask the people at the calibration office, right, exactly what they were doing when they were calibrating the level? Is it horizontal? Right, are you sure it's horizontal, right? Because if it's not horizontal, what is it? Right? You not think those sort of conversations would come out, right? You do realise how they calibrate it on the bed. They have a big bed with a load of mirrors. And they sight it up. This line that it sights is over 200 metres.
Yeah, and they use it like at a...
And yeah, it's accurate to the millimetre. It's, you know, it's that fine that they are absolutely certain that when the auto level was in its position and it's levelled and you get the bubble in the correct position, then the auto level, the line of sight that you see, is horizontal. That's what I was checking, and he said yes. Now, do you think that, because that tool does that, do you think that means the Earth's flat? Or I've just told you that the Earth's flat? Or that guy that told me that he meant that because the Earth's flat? Or is it just that it just so happens to be a tool that establishes a horizontal line of sight called an auto level?
It's establishing a horizontal line. Yeah.
Okay.
I don't disagree with that.
Fantastic.
But like probably that Roddingson or whatever his name was.
John.
John. Okay,
yeah.
John.
Just call him John R.
John guy. He knows you, right? You know who.
He's he's a really hardcore troll on Twitter. Yeah.
So like it was he was fucking with you, right?
Yeah, he was trolling, wasn't he? But I mean, do you think it's okay for people to do that sort of thing? You know, contact firms.
Of course not.
No.
Well, no.
And misrepresent what you've said just because you want to push a narrative.
I don't know what his purpose was.
With a flat Earth. Do you know what the flat Earth is? I mean, have we been over that?
What,
like
a flat Earth is?
Yeah, flat is two-dimensional object, right? And the Earth has mountains and valleys, so it's not flat.
Yes, obviously.
Okay, so it's a misnomer, right? To say flat Earth or the Earth's flat. I couldn't ever say that, right? And I never would say that.
Yeah, but when we say Earth is a sphere, we don't mean a perfect sphere either.
Okay.
It has mountains and valleys still, right? So
Okay.
that's what we mean by that.
But you do have
shape of it.
Yeah. You do have spherical geometry, which is the geometry of a two-dimensional surface, right? So, like, within the concept of whatever you're talking about, you still have the framework of a two-dimensional surface. Right?
Yes.
Yeah. So, I mean, there's not that much different. I mean, I just say the actual two-dimensional horizontal plane is on the water. But that's, I mean, because a water level is a tool for establishing a horizontal plane of reference. I mean, that's all I say. I say level is horizontal, right? Just like the calibration guy said,
everybody
right?
thinks you're saying now. You're thinking that the Earth is flat. That's what.
I know that exactly. You've just done what John did, right? You've conflated me saying level being horizontal with the Earth being flat. I mean, you've done that, not me.
But you can say that.
I just told you there's mountains and valleys. They are not flat.
I know that, but if you're asking me, do you think the Earth is a sphere? I'm gonna say yes.
I'm not asking you that. I'm not asking you that because you've just said.
I know.
You can't know because you've never seen a curvature or anything.
No, but if you.
But I can just as much ask you. Do you think level curves?
Oh my
right.
God.
To keep it basic, right? Because you must be able to prove a curvature from a straight line, and I would be the same. So if I can have a horizontal, then I can measure the drop, like Jesse Kozlowski says. You say that it curves the water level.
At the water level.
Yeah, just measure a drop from the horizontal then, right?
No.
It's as simple as that.
Level at this. Water level measures level at the spot.
No, a water level is a tube that's got two ends, and the ends are equalised, right? So it's not at the middle. There's no middle bit to a water level.
Well, that's where it's gonna be most precise.
No. The two ends, the one end of a water level references the other end of the water level.
The whole Koshel's drawing. I understood what you meant right away. That's what you mean by that.
Yeah, I know. You're really confused.
I know you don't understand it, but
No. Let me ask you this question. Straight question. We're standing right beside the pool, or better yet, 1 mile long lock.
Sorry, 1 mile long what?
You know, like the waterways where they move the ships above the land.
Oh yeah, like
what's it called? Shoot.
I know what you mean. I know.
Right. Canal. Yes.
Canal.
So, if we got 1 mile canal, at what point does that portion curve?
It's a curve by definition is something that is curving all the time, right? It doesn't. Where does it curve? It's curving along the whole canal.
Okay. You like maths? Can you give the maths when a 1 mile gonna curve and you're in the middle?
You're asking me when it's gonna curve when you're in the middle?
Yes.
It's curving all the time along the whole stretch of the canal.
No, can you point it out?
You want me to point at the fictitious canal?
I'm saying, can you point it out where it starts curving? If the water is level.
It's curving all the time. It's curving from 1 millimeter away from where you're standing. It's also curving.
Have you seen it?
Yes, we do see curve.
Can you use any geometry to measure that curve?
You can use geometry to define what we are seeing, yeah.
Is there a dip angle on a curve?
Not using geometry to measure it, the curve. Geometry is math.
Alright. Are you done, Redman, or is he?
Yeah, you go ahead.
So, like, you can do geometry. And which geometry are you imagining you're going to use? Back to it again, right? We seem to be going in a circular path again, right?
In a circle.
Are you going to use Fight the Flat Earth geometry?
No, it doesn't actually matter what geometry I use, as long as it's something that can represent the sphere in a way.
As long as you can represent a sphere and imagine a curve.
I'm talking about...
In a way.
No. No. I'm using a sphere to explain why I would see something which is dropping away in the distance.
A Euclidean sphere, right?
It doesn't matter whatever you...
Oh. Have you got any other definitions of a sphere?
Yeah.
Oh.
No?
Can you offer
geometrical shape of a sphere.
Yeah. Euclidean geometrical shape.
The geometric.
Yeah.
Yeah. Okay.
Why does Euclidean add anything to it?
Because that's where you get your definitions for these things from.
Oh, I don't...
And you've only got Euclidean. You've got nothing else, no?
I don't use anything else now.
Okay.
So you just use Euclidean. That's all you can bring to the table then.
It's all I can bring. It's good. It's an explanation on how things would look over a sphere.
Okay.
No, so all you use is Euclidean. That's what we're asking, yeah?
Mm-hmm.
Yeah.
Okay.
So you know that perpendicular is two straight lines then, right? And
perpendicular to what?
Well, perpendicular is two straight lines as defined within Euclidean geometry, the only geometry that you say you use.
Yeah, something perpendicular.
So it's two straight lines. Right?
Yes.
Okay.
Yes.
Now, vertical and horizontal, are they perpendicular?
Oh my god, I'm gonna do this again.
Yeah. Vertical and horizontal, are they perpendicular?
You're not here to discuss or debate anything. You have your idea, Bell. I already said
it's not an
100
idea.
times what I...
Can you answer the question that's been asked or not?
Asked. I can answer that for the 20th time, yes.
Well, go on then.
Okay, so a vertical line and a horizontal line is straight. Was that what you asked?
Are they perpendicular?
Perpendicular.
Yes.
Yes.
At that spot, it necessarily is.
What spot? What do you mean? What's a spot?
If you're gonna apply it in real life, you would say, then yeah. Because for me,
You would say what?
Vertical
What would you say?
What's your definition of vertical and horizontal in this
No,
case then?
perpendicular. Right?
Okay.
Yes. Perpendicular is
perpendicular
two straight lines, right?
Yeah,
not a straight line and a point, and not a straight line and a spot. Two straight lines.
Lines are two lines which are perpendicular.
Yeah, okay,
yes.
right. Now, okay. Now,
That's right.
are
Good job.
vertical and horizontal perpendicular?
Then I'm gonna ask you what is your definition of that?
What's my definition of?
Vertical and horizontal.
Vertical is a plumb bob, practically, because that's what vertical is.
Okay.
It's a practical position measured by a plumb bob, right? And a level is a horizontal, as marked by any tool that is called a level, because it establishes a horizontal. Now, the level and the plumb are perpendicular to each other. Are they not?
That spot, yeah.
Spot.
Yes.
Right, go back to perpendicular. There are two straight lines.
You're using the definition as a plumb bob, and then it's really fucking important that that horizontal line is established at that
It's
with that plumb bob.
perpendicular. It is a straight line.
I know that.
Okay.
But horizontal, if it's supposed to be perpendicular to the plumb bob, then it's better be placed. Then you better create that perpendicular line at that plumb bob, not anywhere else.
Anywhere. It's a straight line that comes off
I know
90
that,
degrees
Jesus
from
Christ.
that. Right, okay. Now, that horizontal that you have just made that is perpendicular, do you think you can drop another vertical that would be perpendicular to that horizontal?
No.
No. Right, so vertical, in the particular case where you've just said no, then vertical would not be classed as being perpendicular to horizontal, right?
Yes, it
Okay.
would. That's why I'm saying local horizontal.
So when
That's why
I said
don't
is
use the word-
vertical,
Dev, how many times did I tell you? Don't use the word horizontal because it's gonna confuse people because you're talking about two different horizontals.
well,
And you're saying,
like,
no,
see, you know,
I'm
it's
supposed
you're
to
the one
use
that's getting
horizontal.
confused.
Two different
No,
horizontals.
I'm not going to confuse
Bad
you,
wordings
mate.
to explain this. It's just words you use to explain something. And when you use the same word, which are two different lines, then of course
listen.
people are gonna be confused.
Yeah.
So
Funk,
why are you
where are
using
your
horizontal?
where are your two different horizontals? Because I
They are
know
at two
Bev
different spots.
I know Bev's talking about one horizontal. Now you've just brought a separate horizontal into the mix.
That's because
Where did you get this? Where did you get this second one from?
For the same reason, the two verticals are not parallel. Of course, the two horizontals are not parallel. Why would they?
But the two verticals are. The plums are.
Yeah, what do you measure the angle from? We keep going over this.
Yeah, this is something I'm talking about now. Now you're talking about actually measuring something in reality, right?
We've always been talking about measuring something in reality, mate. You're the one.
Are you able?
You didn't think reality mattered earlier, did you not?
Well, why? If you already thinks that all plumb bobs are parallel, why are you asking me that question? If the plumb bobs are parallel or not?
It's fun watching you make up geometry to support some dude that's just making up something that's similar that you do.
You know what I'm gonna answer.
You've got a lovely circle jerk going of all of you guys that are just going, oh, you think straight lines bend too, do you?
But asking the same question over and over again is not gonna change my answer.
I'm not. No.
I'm just gonna tell you here now.
Yeah.
You can ask me 100 times more. I'm never gonna change my answer.
I know you know nothing about measurements. You know nothing about surveying, and you don't seem to understand a whole lot about the geometry that you're making up. You don't even know that much about Euclidean geometry, to be honest with you.
The last one, I think you are misunderstanding.
Do you want to say that again because you're mumbling into your pillow?
I think he's been drinking.
I'm not speaking into my pillow. I'm using a headset.
Well, whatever, you're mumbling.
I'm not mumbling, but it might be. I know it's a little bit poor sound quality on the headset.
Yeah, sounds like a mumble.
So, do you want to make your point again?
My point is that you can ask these questions as many times as you want. As long as the two plumb bobs are not parallel, then the horizontal lines will not be parallel as well.
How do you know the two plums are not parallel?
It doesn't matter, really.
How do you know? How do you know?
Just are.
How do you know? You're making a statement. You're making a blanket statement
then you can
here.
Call the geodetic surveyors and ask them.
How do you know your two? Is you making the statement? It's not them making the statement. It's you.
Call the
I'm
geodetic
asking
survey
you.
and ask them if two plumb bobs are parallel.
They're not making the statement. You are,
Plumb
and
lines
I
are
am
parallel.
asking you how
Are
you
you-
know that your two plumb lines are not parallel.
Direct measurement.
Yeah, measure.
Oh, look, we've got a
And
saviour.
how-
It's been called
How
in.
do you directly
Jesus
measurement?
Whoop, call a baller,
Stop.
call a baller.
You're a fucking
How
retard,
do you
bro.
directly measure the two plumb lines?
Go ahead, Funk.
Okay,
It was
so
you that saved
I
the
know
day there, Flurf
I
and
know
Nerfer, so
Please stop using that.
He's come in
You
to help
said that
him.
I came in to save Kosho. Stop playing this
I
game.
know you failed, and Kosho's done a runner. He's left you here with an angle in the sky.
You're here for
hang on.
entertainment. Stop.
Let's get back to these measured
Thinking
plumb
this is
lines.
something more
How
than
do you
it is,
measure
really.
the divergence of your plumb
It's
lines
not some
then?
grand conspiracy where people go
Come
around
on,
saving
Funk,
each other
stop
from flat earthers.
Stop obfuscating.
Concentrate, Funk.
How do you measure the divergence of your plumb lines
No,
from
don't
vertical?
ask him how he measures it, because he doesn't measure it. He's never done any measurement. Ask him how he imagines someone would measure it. Right, that's the best way to go about it, I think.
Yeah, if you measure the angle between the two level lines, if you create two level lines from each 2 points, and if you know the elevation you are at, you will be able to figure out whether you'll hit where you hit the target at the distance.
Figure out how. How would you do this figuring out?
It sounds like the one we went over with
say,
Jesse Kozlowski and his 1 mile
yeah.
level line.
So
You seen that, did you?
I would imagine. I know the principle. I read something about the principle.
Did you not watch? Me and Cleary did that. We went over it, and Cleary went over it again today, I think.
Somebody else
I'll explain it for you guys.
Somebody. Okay, I'm cannot finish my train.
Yeah, Flurf and Nerfer jumped in then. Flurfer, can you stop interrupting Funk,
it's
please?
you, Bev, who's interrupting all the time. Jesus Christ, Bev.
Flurfer, can you give him some space just to answer the question? So go on, Funk, off you go.
Okay, so I know the principle behind it, and you
But
guys
you don't
can
actually
correct
know
me if
what
I'm
you're
wrong.
talking about.
Admittedly.
How would you know? I haven't said anything yet. Maybe
Because you've admitted you don't know anything about geometry. You've admitted you don't know anything about measurements. And now you want to go, oh, I know it in principle.
No, I think I know the principle behind it, and I said you can correct me if I'm wrong. Is there anything wrong
You're
about
wrong.
it?
Yeah, you don't know the principle behind it.
So
yeah.
you don't know. So you don't know what I'm going to say yet, but you're still saying I'm wrong. Why don't you let me give it a go, and you can tell me if I'm wrong? Right?
Go on, imagine away.
Okay.
We were giving you space.
So can anybody say that without interrupting me and saying I'm wrong?
Well, we
before I'm
gave you
even
space,
speaking?
and there was dead air.
No, you didn't.
Yes, there was.
I
The air
said,
was
let
dead.
me explain, and
keep
you
talking
said,
over him,
I
guys.
said, let me explain, and you said, you're wrong. That's what you said, and I haven't even started talking.
And then there was dead
Jesus
air,
fucking Christ.
and you didn't say a fucking word.
You guys
So
keep interrupting him.
Get on with your
You
explanation.
guys keep interrupting me. You're interrupting
Yeah,
me
Flurfer,
now,
stop
for fuck's sake.
interrupting him, please.
Yeah, please,
Shut
You
the
guys are
fuck up,
interrupting him.
Bev. Jesus Christ. So is the floor mine, or will you interrupt me? Is the floor mine? Yes or no?
You're interrupting yourself.
Yeah, will you say we're interrupting you if we give you an answer now?
No, you can interrupt me after or you can talk when I'm done.
Okay, carry on then.
So,
We'll interrupt you whenever we find out you're wrong, okay? Off you go.
No, you can interrupt me after
for
I'm
fuck's
done.
sake, just get on with it, will you? Jesus.
Okay. So the principle behind this is that you have these tools. You need to know your elevation where you are at, and you are, and you need to be sure that the instrument is level leveled. And if it's one of the, I know these newer tools has a laser guiding laser finder, which is finding each other's target automatically. But let's say you're using a manual one, then you would have a guiding what you call it, like a guiding spot inside it, where you're looking through a with a reticle where you have a cross inside it, and that cross would have to be level, right? And what you're looking at the distance, you need to know the distance to what you're looking at, and you also need to know the elevation at what you're looking at as well. So I think it's quite normal to use like a stick to point out which has so you know what distance you are above that place. And then you can also use so basically that's how you would know how you would know the shape of what you're looking at in the distance. So I'm done.
How from that did you measure the divergence from your plumb lines?
Because if you do the same at the opposite side, both of the instruments would point above each other, even though they should actually point at each other if they are at same elevation. Of course,
How are
they
you
might not
measuring a
be at the same.
divergence? How are you measuring a divergence in plumb lines, though?
Because you can see how many centimeters or meters above the target you are aiming at a distance, and from that we can create a triangle, as you mentioned earlier.
Check in the debate discussion. Have a look at that. See whether you. Is that explained?
What?
Should you have brought something like that, Funk? Would you imagine?
He asked a question. If he was wrong, I'd like to answer. Yes.
Yeah, he was. It's all imagined, right, Dave? They just imagine everything, right, Funk?
Right. Hang on,
He did
Funk.
better than what I thought he was.
Yeah.
Funk.
Okay.
To measure the divergence from your vertical plumb lines, you would need to measure the point at the top of each theodolite. Just say, for instance, they're theodolites. No. So you measure the point at the top of each of them, and then at a set distance above each one of them, you would have to measure another point and figure out the divergence between the 2 points.
What's the first point you're measuring? What's that?
The first point is the top of the machines, right? As an example, right? You got 2 machines.
So that's the line of sight which we are.
Hang on a minute. We're measuring the divergence of the plumb lines. Yeah. So the top of the machines. Say the machines are a mile apart. Okay. So there's your first point. So you got a mile. Okay. Then you are saying that the 2 plumbs that run off of these machines diverge.
Yes.
Right.
So
can I just sort of wait a minute?
How do you make a measurement 150 feet in the air to see the divergence measurement?
Yeah, this is what I've
it's ridiculous.
You've got quite a job here, Funk. I know you've tried this, right? And you're very brave to come in here and imagine this. Looks like Flurford might come in and help you here now, right? But how do you imagine? How do you imagine that they set that particular reference, that vertical within the tool?
Have a plumb. You can have anything that is.
You don't have a plumb at the bottom of a theodolite, no. So.
Oh, I know you don't have, but.
Okay, right. So how do you imagine then that they set that? How do you imagine that they set that? particular
How they
position.
how,
Yeah.
I'm guessing the theodolite which I'm talking about now have more manual calibration setup where you're adjusting it.
They
Probably
adjust the
according to-
vertical manually.
Maybe it's like a tiny spirit level inside the equipment.
Yeah. So what they do is, I'll give you a clue, right? They set a horizontal, and then they use geometry in the 90-degree rule to just measure up from that horizontal 90 degrees, and that gives you your.
I was about to ask, where is horizontal? How does it know where that is?
Because that's an equilibrium, right? That's a horizontal.
Of what?
Yeah, that's your level, right? So you've got Plum, and he's coming in to help you, right, Flav?
No, I'm literally asking you. I know how we can figure out what Plum is, and from that you can figure out where level is.
Yeah.
It's not the opposite way around.
What you can't so you're of the opinion that you can't establish a horizontal, and you don't have a horizontal frame of reference at all. No, and so you imagine then, right? Okay. Well, listen. This is why the test is quite important, right? Because if we can establish that level being horizontal is a straight line, then all of the perpendiculars from it will be parallel, right? Because the baseline horizontal is a straight line, geometrically straight.
How would you construct these perpendiculars?
How would you
construct these perpendiculars along this imaginary line?
You just establish that level is horizontal, straight line.
Yeah, that means nothing. Those are empty words.
What do you mean it means nothing? That's your baseline, right? That's where you start. That's where you start. Come
How
on.
do you figure out? Tell me in practical. How do you establish a horizontal line in practice?
With a tool that establishes a horizontal. Now, I can test that a water level establishes a horizontal line. Now, you can check that if you get one that's long enough with an auto level. You could come with a theodolite. You could come with a total station. You could come with spirit levels.
A spirit level is.
And you could then check that the water level was horizontal.
Those are empty words.
I know. I mean, I understand that you guys don't think surveyors can establish a horizontal straight line.
Yeah, they use a theodolite, and the horizon is always below that horizontal.
The horizon.
Let them talk.
And Fleff is getting triggered. I know. This is your sort of subject, is it, Fleff?
It's got to be Veej.
No, I think it's possibly the main surveyor or something like that, right?
Who's that?
Fleff.
Nobody.
The main surveyor is that's his picture on the thing. KC says, and with the parallel lines, plumb parallel lines, right? And because it's got his name in the bottom right-hand corner, the main surveyor. And it's like all imagined geometry. It's like defending Fight the Flat Earth geometry, right, Fliff? I mean, that's what we're doing now, right? Bendy straight lines.
Mr. Giggles.
Be able to talk about any subject rather than discussing drama and things we don't care about.
No, he talked about a level line.
No, he did not. He talked about how Giggle is here to defend Fight the Flat Earth. Giggle is here to defend the other Globers.
Is that Giggles
what
then?
About talking about
is that Giggles or is it the main surveyor? Or is it both, perhaps? I mean, I don't know.
Why don't you guys talk about something that can actually be constructive in here rather than...
Well, the main surveyor is one of your top guys that says he's measured it, right? So would him not having him around be a cool one, right? I mean, if it is him, it'd be a good idea for him to speak up, wouldn't it? Because he's actually.
You're not asking him anything. That's the problem.
He's gone quiet.
That's why he's not responding.
He's gone quiet
That's
because you're
not
speaking
asking
for him.
Anything, Bev. No, that's because you're not asking him anything.
Okay.
You're just talking
I'm gonna put
shit.
him on mute.
Flurf,
Right?
Flurfer, are you the main surveyor? And can you help us with these parallel plumb lines not being parallel or something?
Plumb lines are not parallel.
Oh, have you measured them to not be parallel?
No, but someone else did.
Oh, who? Somebody.
It's every single surveyor.
Right.
Can do it.
Are you the main surveyor or not? I mean, I know the main surveyor isn't a surveyor and would answer just like you've just answered. So,
No, he is.
Are
Sure,
you the main surveyor?
No.
No.
No, I'm a surveyor, but I'm not the
Oh,
main
you
surveyor.
are a surveyor. Nice. So, have you measured that plumb lines aren't parallel?
No.
No. Oh, you've never done it yourself? Okay.
It's in the surveyor manual. Everyone else has done it. Yeah.
Have you?
It's established.
How would you everyone has done it.
How
Oh, that's easy. Here, let's talk geometry since you guys are geometry experts.
Are you?
Let's imagine that. Hold on, I'm talking. Be quiet.
Imagine. You want to imagine geometry? Oh.
Warfare, you said everyone has done it, and you're a surveyor, but you haven't done it.
No, I say it's been established
By every other surveyor, except you.
by the whole field of surveying. It's established. We
Except
don't
you.
have to repeat every single measurement in the entire history of
Or-
science to
or-
use them.
History of science.
Is
Science.
he
all the
Yeah.
minutes.
Wow.
One at a time.
Upgraded
About
it.
geometry.
Nice.
Since you guys are experts in geometry, you're going to start talking nonsense.
Is that science though? What?
I asked how you would do it, and
Okay,
you're
and then
just
everyone else interrupted me.
skirting around the question.
No, I'm trying to, but everyone keeps interrupting me about other stuff.
Go ahead. Go ahead.
Okay, great.
DP. Sorry.
Yeah, so let's talk about
Go ahead.
geometry. So,
No,
Shut
just
up.
how,
Wait.
how would you measure the
Why are you
divergence
interrupting
of
me?
plumb lines?
I'm going to answer your question if you stop interrupting. Good God. Okay, so if you have a
You do one
rectangle,
more
what are the...
time.
Why are you interrupting?
You came in here. Watch yourself.
Shut the fuck up. You ask a question and then you start talking.
Wait, keep the language
Fucking
to yourself.
Oh, you are want to fight the flat Earth's men, aren't you?
What are the internal angles of a rectangle?
Once more,
What are the internal angles of a rectangle?
is that a rhetorical question?
Oh, no, answer it. You guys are experts in geometry. It should be easy.
Do you want the total, or do you want each individual one?
The total.
Yeah, 490s, 360.
490, 360. Yeah.
Okay, so if I have the same... If I
Are
have
they-
that rectangle... and
sorry,
then I make
wait a minute,
one
wait a minute.
side-
Are
Why
the
you
straight
talking?
lines
Shut
straight?
up, I'm talking.
Are we
Shut the
using
fuck up.
Are we using
Shut the hell
the
up,
straight
I'm
line geometry,
I'm
or are we using fight the flat Earth geometry, where we can bend straight
you shut up.
lines?
And what's the angles of a rectangle got to do with the divergence of plumb lines on a sphere?
Okay, I'm going to explain this to you. If you would just shut the fuck up, all of you. Why is that
Just
so
do it.
hard?
Do it.
Are you going to be quiet when I'm talking?
This is the main surveyor, right?
Do it.
Off
Get
you
on
go.
with it.
Nah.
Off you go, Jeff.
Okay, time for everyone to be quiet while I teach you.
Go ahead.
Okay, so take that same rectangle and shorten the left leg and raise the right leg slightly. What are the internal angles now? The sum.
Here, go.
Come on, geometry experts, come on.
Are we allowed to speak now?
I asked you a question. Time to talk.
Oh, okay. Sorry, I was waiting for your okay for us to talk.
You're stalling.
What was the question again?
You heard the question. Quit stalling.
Come on.
You changed the angles of a 360-degree rectangle.
Oh, but it's still a rectangle.
It's technically not a rectangle anymore.
Still has the same internal angle. Some of the internal angles would still be the same.
It'll still be what?
The same as it was before.
360.
So this still doesn't answer the question as to how you would measure the divergence of plumb lines.
I have to walk you through it. So what if you took a theodolite and pointed it at another theodolite, and then you measured the angle between plumb at each theodolite?
At what distance?
This is what I'm trying to establish: how
3
you
miles.
measure the angle between
3 miles.
the plums.
One at a time. I'm explaining it to you. Why are you not listening? You're talking.
3 miles.
Well, a rectangle has nothing to do with measuring the divergence of the angles between plumb
Yeah,
lines
it
from
does.
two theodolites.
Sure it does, because a rectangle represents a flat surface on the bottom and 2 vertical plumb lines. So if you point theodolites at each other and you measure the angle between plumb at each location and you're on a flat surface, you would get 90 degrees at each one. And the sum of the internal angles of the rectangle created by that would be 360. But when you do this in reality, it's not 360 because the Earth is a sphere.
Not you've done it though.
Okay.
You've just done it in
At
reality.
3 miles, he said.
Yeah, he's not.
Well,
he's
he got
not done
he
it
did
though.
it all right until he said the last line.
Yeah.
Because of the sphere.
Yeah.
Bev, ask him again.
What?
So have you done this?
He's not done it.
No.
He admitted he's not done it.
No, I haven't. But
No.
other people have.
So it's just imagined then, right?
And he's still not given the answer to the question either.
Yeah.
I did. You guys keep talking about something else.
I've got another theory, right? What do you reckon this could be? Cosmo and also the main surveyor.
Oh, so we're changing the topic?
Yeah. Well, I mean, similar topic, right? We're trying to
I'm not
decide why you get so triggered about all sorts of things like this, right?
Okay, well, I'm not going to participate in that topic.
Yeah. Get out of here. Bye-bye.
Hey, Crookshank, you went over the topic of plums already on this channel, so why you want to mention it again? Come on, Crookshank.
You guys asked, and I just proved you wrong.
Yeah.
Oh, so you're Crookshank, huh?
Yeah, he's Crookshank.
And Cosmo and the
You got a
main
voice recorder.
surveyor.
He's online. He's on YouTube already.
I'll await any rebuttal to my topic.
You're definitely a surveyor then, right, guy?
Irrelevant.
Yeah, irrelevant. No, you did claim to be a surveyor at the beginning of this conversation.
Irrelevant. I'm answering the question that was brought up.
Irrelevant. The fact that you've never actually done anything, but you're speaking on behalf of an entire profession about your imagined thing in defense of Fight the Flat Earth geometry.
I just explained rectangular geometry and it confused you guys. So I don't
Rectangular geometry, is that a new one?
No, I didn't. I am a surveyor. Are you a surveyor?
You are a surveyor.
Bev, are you a surveyor?
I have a surveying qualification, yes.
Liar.
Do
Liar.
you?
Why
Sorry?
are you lying about it?
What do you mean?
You're
What's he talking about? Liar.
What was Rocky talking about when he called me a liar?
Well, I can show you my qualification, right? Do you want me to put it in the chat?
That can be easily faked.
Your papers.
It can be faked, can it?
Yeah. Sure. Astronauts have papers that say they're astronauts.
Oh, so you're saying they're fake?
It's like you're saying you're a main surveyor. I'm not that Crookshank. You're a surveyor, huh? Well, you're not. You're lying.
I am, but that's irrelevant.
You are.
Who's the liar now, huh? Who's the liar now? Come on.
He was honest about him lying, right?
You're a liar.
What? Who's a liar?
You are. You're not a surveyor.
You're just throwing this. No, I've never claimed to be a surveyor. I have got a surveying qualification, though.
No, you don't.
Yes, I do. Wait, you're just saying that? Yeah. I know.
If he can just say it,
Yeah,
then
so
so
wait.
can I.
Who can say what? You've just admitted you were a liar. You're not a surveyor. You've just said
I
it.
said I wasn't. When did I say that?
Just.
No, I didn't. I am
Yes.
What a lie.
Oh, Jesus. Are you seriously one of the best ones that they've got?
Why are we so off topic?
They've sent you in here to make a fool of yourself.
Made a fool of you guys.
Or did you offer yourself up for this?
Are you jealous that I'm a
Bev,
surveyor and you're
something,
not?
Bev.
I'm finna give him the boot.
You haven't matured a lot since your man. Jesus Christ.
No, because
Are you guys
last
mad that I just proved you
conversation
wrong
I
about
had
plumb
with
lines
you,
not being parallel?
equatorial amounts proved the
You
globe.
guys are debating.
Oh yeah, let's talk about that.
His topic is.
You want to talk about that?
I'm just finna kick. I'm finna kick him. I'm finna kick him. That's all
Hang
it is.
on, Redmond. Before
You
you do
guys
that.
beg me to come into VC, and then you can't even
Yeah,
hack
really. Yeah, really. Flurfer, how do you
Oh, wait a minute. Are you John? Are you John R. as well? Is that why you've come in? You also, is that why John R's not come in? He could be.
So why do you guys
Have you been triggered in, John?
that you can't even handle what they have to
He
say?
heard
and
us.
then-
He heard us talking about him.
Yeah.
So do you guys have anything on the topic, or are you just going to deflect and run?
John,
from it?
yeah, John's got
I
a good
have asked
defence
you-
on Twitter
I
as
have
well.
asked you how you measure the divergence of plumb lines.
Oh, I haven't done it personally, but I can tell you how it's been done.
Have
Waiting.
you give us
No,
anything
it's
that
easy.
you
Okay,
have
take
done?
Yeah. No, I haven't done it personally, but it has been done. This way.
Anything
So
you have done, though?
Shut up. I'm explaining. I'm answering his question. I'm not going to respond to anything else. So you take two theodolites, you point them at each other, you separate them by some distance, and you measure the angle of each theodolite relative to the local plumb. It adds up to more than
Can I
180
ask?
degrees.
I'm gonna ask a question. So how does a theodolite work really?
It's a device that measures angles very accurately, and you can incorporate a plumb line in it, and then you can measure the orientation of the theodolite.
Incorporate a plumb line in it.
Okay.
And
why you interrupt?
how do you measure?
One
how
at a
do you
time.
measure-
Wait.
No. One at a time. Everyone shut up. Redman, go.
I'm going there. There again. So what are you angling to when you look at the other theodolite?
You're angling to the other theodolite.
All right. So how far can you see with a theodolite?
Miles, many miles. Depends on
No.
atmospheric conditions.
Give me the miles.
There isn't a
Honor?
solitary number. You can see the sun, you can see the moon, you can see stars. Long distance.
I said theodolite. I didn't say the sun, moon, or the stars.
You can see any of those objects. Anything that's in your field of view, no matter how far it is, you can see with a theodolite.
And you can
So 1,000
accurately get
Redman, be quiet.
measurements,
Redman's
angle
talking.
measurements.
Quiet.
You can
Redman,
accurately
go ahead.
get
Shut up.
the angle measurements at 1,000 miles. Yeah, is that what you're saying? He's a retard.
Redman, go ahead. So everyone else keeps interrupting.
See,
you. I
I've
don't know
I've just done a picture there. I put theodolite in, and I went to look, and that comes from zenithsurvey.co.uk. Shout out to Zenith Survey, guys. They're the ones that I got my level calibrated from. Where would you hang a plumb bob, or where would you incorporate a plumb bob in that, please, John?
Not a plumb bob, you dumbass.
John.
Oh my God.
Well, where would you incorporate a plumb line in that?
Plumb line in the dev. You're so fucking stupid, man.
One more.
Yeah, Flurfer Nerfer, right? Flurfer said that about that, right? Incorporate a plumb line in it. Funk says you're so fucking stupid, Flurfer. Yeah.
So you tell me a theodolite cannot tell you where you are relative to plumb?
Funk, tell him.
Huh?
Tell him.
Are you asking me for?
Yeah, he's on about incorporating a plumb line into that machine. Tell him.
Accelerometer is able to determine where plumb is.
You've just called Bev a retard for thinking you can put a plumb into that machine.
Well, he's
not a plumb bob.
That is exactly what Flurfer's talking about doing.
No,
so
I'm not.
you've just called Funk.
Do you know how many different ways there are of establishing vertical?
A retard.
You can use accelerometer. It's quite common inside other equipments as well. But I think it's other ways to establish
Yeah,
it.
you guys seem to think
precise.
that a plumb bob or a plumb line, like a string and a weight, is the only way of establishing vertical, like the local vertical, and that's just plain wrong. There's lots of other ways. You can
Plain
use
wrong.
a pendulous weight.
It's
a pendulous weight with potentiometer for angle measurement.
Pendulous weight.
It's on
That's
that.
not the same.
It's
Is that
on
not
that
the same as a plumb?
theodolite. If you're looking through it, right? See that adjustment thing that you make in the middle, that telescope, right? That's your vertical. You move that up and down to look at the vertical. The horizontal's all set by a different thing, right? And so it's set at 0 for horizontal. So the vertical within that telescope that's right in the center, how do you imagine that you put a plumb line in that? Either of you guys, please.
An accelerometer is able to determine where
Wasn't
Down
what
is,
you were asked.
and down is plumb line basically. My
A plumb line doesn't have to be a physical string. That's really like archaic
No,
technology.
how do you establish a plumb line in that, please?
using an
You have an element
accelerometer
that
is
hangs.
one way.
You have an element that's under the influence of gravity.
Yeah.
It could be an accelerometer or a pendulous member.
Would you not just set the horizontal and then measure 90 degrees up from that?
No, because that's established first from a plumb line.
Oh, right. You have to have the plumb line there, right? You can't just go from the horizontal, can you not?
That is the native mechanism for creating a datum because you have access to that everywhere. It's a primary datum.
What, the horizontal? Or the vertical?
The vertical is easier to establish.
That's a datum from where?
It's a datum for establishing vertical.
Yeah, but where do you get that datum from? The vertical datum?
Any kind of member that creates a plumb line.
Okay.
Circle
jerking,
circular answers.
He's obviously a professional surveyor, right?
I don't know where you're going.
Obviously.
You guys ever seen a laser?
Circle jerk.
Circle jerking circular answers.
Okay, you guys just gonna ask questions and talk over me?
Yeah, so I'm gonna keep on talking over you. I'm gonna call out all your names: Crookshank, Mr. Giggles, Road Reflector,
Main surveyor, John Rawlinson.
So you obviously don't want to hear the answer because you know I'm gonna make you look dumb.
Yeah,
Crookshanks. Yeah. Can we go back
let's,
to
let's give him some space. Let's give him some space because
He's
you know
gone.
He's gone.
He's gone.
He's gone, has he?
Yeah, he's gone.
That's Crookshank.
Fucking dickhead.
Always when he talks, he's got such voice from trolling voice.
He thinks he's a baller champion, Funk. Do you mean, what do you think about people like that come along?
I think he is quite knowledgeable.
You think he's quite knowledgeable? Do you think he's a surveyor? Has he convinced you that he's a surveyor?
It's that hard to be a surveyor, right?
You don't think it's that hard?
You're funny, Funk. You think he's quite knowledgeable.
You don't think it's that hard?
Even he could do it.
You don't think it's that hard to be a surveyor, yet you don't believe a surveyor can establish a horizontal line? A straight line?
I do believe, but I don't think you understand what when you're asking that question, what that actually means to me, you know.
Funk, do you think plumb lines are not parallel or what? Like he does?
Yes, and I think I've already answered this question at least 20 times.
How would you measure the divergence of plumb lines from parallel then, Funk? How would you do that?
You could use the way he said, or I think I also
Yeah, but he didn't say anything.
He did.
Did you ever walk with plumb lines or not for fun?
He actually said nothing.
No, he said
yes.
You're pointing the.
Can you give us your version, please? Can you give us your version, not anybody else's? Because any man
here. I
here.
gave my own version before that, bro. Do you remember what I said?
Nope. I want to hear it again, please.
Okay, so I said you can point the theodolite at level, and you can, if you know the elevation of the observation, you basically will create a triangle between what you're pointing at and down to the theodolite.
How do you measure the angle at the tip of the triangle?
Using a plumb line.
You measure an angle using a plumb line.
And a plumb line
you
that
need
isn't,
a plumb line. It's
that
an
isn't
angle between
perpendicular.
It's a plumb line. The plumb line is you measure the angle between what you're looking at and the plumb line, basically. You know what? Let me retract that. In my way of measuring
Rather,
it, you
rather than
actually
measuring
don't
the angle to the horizontal, you want to go all the way. Just add 90 degrees onto the measurement of some sort of drop from horizontal. Or is it the word horizontal that's a dirty word now?
No.
Is that a flat earth word now? The word horizontal?
No, you can use the word horizontal.
Ooh, that's a flat earth word.
No, you can use the word horizontal.
Hang on, Bev. He did retract what he was. I think
Yeah.
he got his own head
Oh.
modelled up. So do you want to run through that again, Funk? Sort your own head
Okay,
out.
so what I'm
Get your
saying is that
get your
if
head
you're using my
unfudged.
method, so if you're using my method, then I
Didn't
would
you?
say
Didn't you
would.
just use your method though?
Yeah, but I didn't finish it. If you were
You
to listen.
repeated it from before. So wasn't that your
Yeah.
method?
But what I was retracting was the fact that I said that you need to know the angle between the plumb line and what you're looking at, and you don't, because you're looking at horizontal, and that's basically 90 degrees already. So you're looking at 90 degrees
Your
out
plumb
from
lines are
plumb.
90 degrees.
Yeah, if you're
your plumb
if
lines
you're
are 90
looking
degrees. This is what we're
horizontal, then
saying.
it's 90 degrees. Yes.
So
Right.
there is no divergence in the plumb lines.
Well, it depends on what you see on the other end, doesn't it?
The two theodolites have got plumb lines each, and there's no divergence in those plumb lines. That's what I've been saying.
You're saying that, but it depends on what we are measuring, isn't it?
Yeah, but I've just asked
Just
you how
say,
you would measure them, and you've
and
said
I
there is no divergence.
just told you. No, okay, then you don't understand what I'm saying. What I'm saying is that if you're looking, I wish I had my computer so I could actually make a drawing or something. But if you're looking horizontal out of the theodolite, and you're looking towards where the other measurement point is, if, in my opinion, if the Earth is flat, you would look straight at that theodolite. But I don't think
If
you'll
they're
do.
at the
You'll
same
look above it.
elevation.
If they are at the same elevation, true. So if, basically.
I got two pictures I want you to look at.
But if basically.
Do you agree or
nothing?
What?
No, go ahead, DP.
Well, he just.
I don't understand why you don't understand it.
He just said if basically, and then finished.
I didn't say that. I explained you how you use the theodolite to look at the other object.
No.
You
No,
might not understand it, but
you went if basically, and then finished your
No.
sentence.
Yes, and what did I say then? Repeat what
Nothing.
I said. Well, then you don't understand me. I cannot help you with that. Sorry. If you don't understand, if you
Redman,
don't
it's all
listen to
good.
me or understand what I'm saying, then okay, move on. It's fine.
Well, all you said was if basically.
Yeah, no, that I didn't say that. But if you didn't understand what I was saying, move on, and you just move on.
You said you wanted a. Did you want a picture or something?
I think you understood it more clearly the first time I said it, Bev.
Right, well,
But for some reason, this other guy doesn't understand what I said when I said it the same way now. So.
All you're doing is pointing two theodolites at each other at the same elevation.
Right, see, there you go. Look at that. See, can you see my picture?
Shouldn't they be pointed straight at each other?
We've got the whiteboard out. Is that what you want? Right, I've got.
If you're looking straight at each other.
Yeah, look on my whiteboard. Look on my video. Can you see it?
Yeah.
Right. Can you see there's two theodolites there? And they're looking at each other. Do you want to explain to me? I can do some drawing, right? Because this is what you want, right?
I don't see two theodolites.
they're there on that line, right? They've got 3 legs. They're only a very basic drawing, all right? I'm not going into extravagant artist mode, right? But they're 2 theodolites. Let's call them. They're just a telescope looking at each other, right? Can you see them? Can anyone else see them? Everyone else see them?
Yeah, I can see them.
Yeah, no problem.
I
Okay.
see railway line, vanishing point, horizon line, telegraph poles, and the road. And a horizon.
Wow. You're looking at the wrong place, mate.
Live stream.
Just my video.
Oh, sorry.
Right.
I'm wrong.
Yeah.
The wrong.
My video. I've got my camera on.
It's hard to look at the phone. Sorry.
Okay.
I do it from my phone all the time. No problem.
Yeah, I'm looking on my phone as well.
Sorry. Let me check.
Should I label these as well? This one's
fine.
A,
I'm
and
looking.
this one's B. You get that?
Yeah.
Point A and B. It's backwards on my screen, so apologies to anybody watching it.
Good.
But it's
Left,
good on
right,
it's
A
good
and
on
B.
your screen. It's bad on mine. So A and B.
Yes.
Now they're 2 theodolites. They're looking at each other. Yeah. Do you want to run us through what you're explaining?
Yeah, that's fine. They're
Okay.
looking straight at each other.
Yeah. Now go on.
Okay, so you want me to explain how I would do it?
Yeah. Run us through what's happening here.
Okay. So first thing I would do is establishing a vertical line, a plumb line inside each instrument.
Okay.
So draw a plumb line on each instrument.
There you go. There's a plumb line on that one. And there's a plumb line for that one, right?
Yeah, sure. Yeah.
Brilliant.
Okay, you can use real plumb lines. It's fine.
2 actual
Okay, so
plumb
there-
lines, right? Just to keep it on point, so we keep in reality mode here.
Fine. That's fine. It's I don't care. So, if they 90 degrees out from that plumb line is your horizontal line. Right?
Yep. Okay.
So draw 2 horizontal lines.
There you go. Like that.
Thank you. Yeah. So that's what we would if we were to see this, I would say, well, that's because we live on a flat Earth, right?
Okay, right. So if we use a level line like I've just done there, and plumb lines like I've just done, in reality, that's what you'd expect to see in reality.
No, that's what.
Yeah,
I would
yeah,
expect to
exactly.
see if
Right,
the
yeah.
Earth is flat.
Okay.
If the Earth is flat, yeah.
Well, just in reality,
I don't assume
using a reality level
measure,
there
right?
that's a horizontal, right? And plumb bobs that are vertical and they're perpendicular to that horizontal, right?
Yes.
Yeah. So what are you imagining? We measure the angle. We're here. This angle here. We measure the angle here. That
Yeah,
angle.
but in this case, this is a scenario
Which we do
where
this
the
angle.
Earth is flat, right?
Do this
So I
angle.
would expect to see this if the Earth is
That
flat,
angle.
right?
Okay.
I would expect to see this if the Earth is flat.
Yeah, this is the reality model. Okay.
I know you.
Now let's run us through. Well, we'll tell you what. We'll
So
take
how
this,
would it look
we'll
like
take
if
this one
you
off
were
because
on
that
a
might
sphere?
distract you, right?
Yeah, but how would it look like if you were on a sphere?
That's for you to.
Yeah, you tell us. Look, because
Yeah.
I've got a water
Or
level
show
here as well.
Create
Look,
a
this is a water
create
level
a curved
here.
surface.
This is
Create a curved surface
This is a water level here.
for me.
Create
Create a curved surface for me.
Bev.
Bev.
There you go, like that. How's that?
It's
Is that
easy.
Is that
it's
curved
easier
enough?
if you draw because you're gonna draw on it.
What?
No. Bev, hold up, Bev. why can't you draw what you want us to see, what you're seeing?
Are you because I don't I'm in my car still, basically. How the fuck can I draw? He
All right,
has
well,
a
you got-
whiteboard, so I guess he can
Okay.
draw.
You want? So what do you
Yeah,
want?
but he,
Right?
A circle.
Yeah, erase what you have there already, right?
Right. You want me to draw a circle,
Not a circle, I said an arc.
an arc. Then what would be the purpose of this arc?
I'm supposed to show you what I would expect to see.
Is this? Are you going to try and suppose that you can move one of these level horizontal lines around that curve?
No.
No, because
I'm not presupposing
we've
anything.
got a few
Is
of
it
these.
that dangerous to much
Look.
make a drawing? It's just a drawing.
Right. See this bubble
Bev.
here?
Bev,
Right. See the bubble?
you
It
had
needs
no
to be in a
issues
certain
drawing.
position.
You had no issues
Right.
drawing that first.
It
step.
needs to
And you're
be
asking
in
me-
this position.
Bev,
This
stop being so
is
fucking
not
disingenuous.
level.
Oh my
Bev.
god.
Right?
Bev, you're able. I played along with
connection
the
might be-
first
might be
example.
off.
Who's
Bev.
connecting funk?
Bev,
Yes.
can you hear me, Bev?
Yes, I can hear you. Right?
Yeah.
Your volume is low.
Okay. So
Right.
play with me on this one.
No,
Bev.
no,
Are you
no.
able to do
Listen,
that?
listen. We deal in
Okay, then
reality.
I'm gonna
This
leave. I'm
is a
gonna leave.
reality tool.
This
right?
isn't a fucking game show, Bev.
This is a reality tool. And it needs to be in a certain position in order to deal with reality, right? It's only level
that
when this
uncomfortable
bubble
for
is
you?
in the middle. This
Is it that?
is not
is it
level.
That dangerous?
This
Is it that dangerous?
this isn't level either.
Bev, how dangerous is it to make a drawing on a whiteboard? Tell me.
No,
Is
just
it that
come back
dangerous to make
when you get home, please. Come back when you get home, so you can draw.
Well, does Bev
So we can see.
doesn't Bev have the capability to draw? It will take
I can
him
draw a
months
circle.
to
Okay,
do
yeah.
this.
Here we go. Right, watch.
Remove this and erase what you have there
you go.
already, so we don't get conflated with something.
Here we go. There you go. There's a curve.
Oh.
You right with that?
I cannot,
Oh, you can't
I
even
can't
see
even
that
see
one.
the line, man.
Ah, right.
Oh, okay,
Remove
so why
what
don't you
already
do it
have there.
yourself?
Here's a curve then.
Because I said I don't have a fucking whiteboard and I don't
Okay.
have
Do
a.
you
I'm
like
in
that?
my car.
Do you like that curve?
That's better.
You like that?
Yeah.
How far
but
is your
I-
house?
Is it big enough curve?
And then
Do you
draw
want it a
two
bit more?
theodolites.
There's two theodolites already on
Two
it.
theodolites.
Yeah. Yep. Two theodolites is here and here. What's up? Has he gone?
No, he's still there.
He's solid green now.
Well, he might have a bad connection. Number one, if anybody is hearing, if you want to make your own demonstration, do it yourself so you can show everybody else. Nobody's a mind reader here.
Funk. Yeah, that's conveniently knackered your system. It looks like.
Yeah.
Sorry, I had some connection issues. Yeah, I guess he doesn't want to draw what I'm telling him to draw, so.
Look,
yes,
Are
listen.
you a mind reader?
No, but I can. But I can speak English if you understand.
What did you ask me to draw? Because they are already there, is what I said. You disappeared.
That's why I told you remove the what's already there before you draw the arc.
Right. What
told
do
you
you want me to do? I've drawn an arc. Come on.
Okay, so you draw two theodolites.
There are two theodolites there already.
Okay, that's why I told you remove those two. Jesus Christ.
What's wrong with the two that are there? Tell me
Because they
now,
are
please.
Because they're not angled perpendicular to the surface of the earth.
No. You see, this is where you were going to come up against the problem, right? Because
I
if,
know
like
that,
I've just
but
explained to you,
is it that
Funk,
dangerous? This is
I have just
hypothetical, Bev.
explained to you, right, the
No, you.
position that a horizontal is in. Funk, stop talking. Right? A horizontal is a very definite position. Don't ask me to draw something that isn't horizontal and say it's horizontal. I can't do it. It's not within me.
Then I cannot help you anymore.
Okay, well that's good then.
You're on your own from now on.
I'm on my own, in my own land of reality, not imagining straight lines curving.
I cannot help you there.
Okay.
I'm asking you to draw a simple drawing.
It doesn't seem like you can help fight the flat earth and his geometry case either.
Bev, if you ask me draw this, I would draw it for you. And if that would help me understand what the hell you're talking about. And I'm asking you to draw something for me so I can explain.
This isn't going to help you understand what horizontal is.
I refuse.
It won't help. It won't help you understand what vertical is.
Strange thing to do, I would say.
In fact, I would keep you away from saying that a tangent is horizontal. That's very dangerous and shaky ground for anyone to be on.
It's not dangerous.
It's imagined. Yes.
It's hypothetical.
It's not reality.
And you cannot engage with anything that is hypothetical.
Not when we're talking about the shape of the earth. No. Because people have called me child abuser for saying level is horizontal. And you want me to draw a circle and pretend that a horizontal can be vertical. Pretend that horizontal can be 45 degrees. Pretend that the horizontal is in fact akin to the circumference of a circle. That's absolutely ridiculous. Fight the flat earth geometry, Funk.
It's a drawing, Bev.
Yes, it's ridiculous. It's not reality, and it is dangerous for people to think that it is.
Well, think about what we think about you, Bev. If you think we are dangerous, what do you think?
No, I didn't say you are dangerous. I said it's dangerous to think that horizontal could be at 45 degrees. It's dangerous to think that horizontal could possibly be perpendicular to horizontal.
I don't know why you have why you're so afraid about that. If that's actually what is reality, then what's so dangerous about that? I don't.
Your reality that you've just imagined. You have
to be honest,
no.
I don't care if whatever that measurement is showing is. I don't care, but it shows one thing, right?
Which measurement?
The measurement which we have been explaining this whole night almost, using a theodolite.
Have you ever taken any measurement through a theodolite?
Doesn't matter if I did it or not. A lot of people have done it, and whatever it measures, why is it so dangerous? Whatever the result is.
No, just the thought that you can imagine that horizontal is not actually perpendicular to vertical.
Well, that's even less dangerous. It's just an idea. It's just a thought. What's so dangerous about that?
Because that thought leads people to say that other people are child abusers, and they get ridiculed. They phone up companies. They phone up companies to conflate the fact that when people say level is horizontal, they mean the earth is flat. There's all sorts of strange things that go on from people with their crazy notions about the geometry that they just make up.
Bev, somebody might call you child abuser or whoever wants to call it. I don't know. Nobody in here I think have done that. So I don't think you need to put that idea that that's something I would think or anybody else. I'm just talking about something very simple. Just
There could be loads of people listening,
on a
right?
whiteboard.
There could be loads of people listening who also
cares?
get called child abuser. I
It-
mean, who cares,
cares?
right? I care.
You're drawing
Because
you're
it's
drawing on a
wrong.
whiteboard
You
now,
shouldn't do that sort of thing to people.
You're drawing on a whiteboard, Bev. Calm down. It's nothing more. You're drawing two theodolites on a whiteboard.
They're already on the whiteboard. There's two theodolites
but-
on the whiteboard. There is a curve in between the two theodolites.
Yes, I know. But
Right, so what is your problem?
Your problem.
What is your problem? You want me to do two theodolites with a curve. There are two theodolites and a curve.
Bev, I'm asking you to place these two theodolites perpendicular to the surface of the Earth. Can you do that?
They are.
Perpendicular to the surface of the Earth.
Like there's a plumb bob. Can you not see the plumb bobs that are there? Right, and the perpendicular line.
I'm talking about the hypothetical on the paper, on the whiteboard. Don't start the
No,
bullshitting
look, it's
me,
here.
Bev. I know you
There's no
understood
need
what
for
I meant and you're just
hypotheticals. Look,
bullshitting
it's
me
there.
now, Bev, because you don't want to draw it. Bev, listen to me now. Can you hear what I'm saying, Bev?
Vertical, horizontal.
Yes, I know, Bev.
There's
Calm
no
down,
there's
Bev.
no hypothetical needed there, right? That is actual.
I know that it's an actual in this room. I'm talking about something that is scaled down.
Okay.
Your whiteboard is
Do you want?
10 miles
Okay. Do you want me to just tell me how to move that vertical and horizontal to the sides, and
I'm
I'll
gonna tell
I'll
you
sort
how
that
to
out
draw
for you.
that theodolite, and then I'm gonna tell you how to draw the plumb line, and then I'm gonna tell you how to draw the horizontal line.
I've just done it. There's a horizontal and a vertical there.
You're still refusing to do it. What I'm asking.
No,
you.
there is already a vertical. In fact, there's multiple verticals and horizontals there.
You need to take a fucking reality check, Bev. You are refusing. Is it anybody here who is finding it kind of ridiculous that he's refusing to draw something on a whiteboard? What's so hard about that, Bev?
He's done
It's
exactly
not
what
dangerous.
He's done
It's just
exactly
a
what you've asked
whiteboard.
him to do.
No, he's not.
Here he is.
No, he's not.
Here he
And
is.
you're being disingenuous because I know that you're understanding what he's saying.
You've
You're
got
just being a
plumb
moron.
line,
Just,
you've got
just for-
vertical, you've got horizontal.
Yeah, there's four plumb lines there.
theodolite, and you've got a curve. You're lucky you got Bev to draw a curve, actually.
Oh my god.
You're really lucky.
Oh, thank you. That was so nice of you. Even though you disregarded everything else about it. Huh?
Okay, so if you want the drawing the way you want it, can you draw it?
As I said, I cannot draw it now. I can maybe draw it on a piece of paper tomorrow, and I can print it.
Cool, no problem.
So
Hey,
does
like to
does
see
it
it.
change? Let me ask you: does it change anything if Bev draw it or if I draw it? What's the difference?
No, Bev drew it just how it is.
I'll do my
No, he
model,
does-
right?
he did,
And,
drew-
and
you
reality
did not
model.
draw-
I'll do
you
I'll
did
do
not
reality.
Bev, you did not draw it the way I
I'll
told
do
you.
yeah,
to.
but I'll do reality. You can do your fantasy, right?
I'm telling you to draw something hypothetical, and you find it so dangerous.
No, I don't find it
What-
so
what-
dangerous. I
what-
just
and
don't wonder
suddenly
why you
start
want me
talking
to
about
be.
child abusers. Bev, why did you start talking about child abusers? out
Because
of nowhere?
people have
What-
called me
what's going on,
a
Bev?
child abuser.
Well, I didn't. So why do you?
Because you are imagining exactly the same thing as these people that call me child abuser.
Yeah, but I'm not calling you a child abuser.
No,
I'm just telling
but you are also saying, just like these other people do, that level is not horizontal. Now you're saying that, right?
Yes.
For a
Maybe
particular
because it's
reason, right?
Maybe
Because
maybe
you
because it's
imagine
true.
that a horizontal actually curves around a big ball.
It's just a hypothetical I'm drawing for you, and you find
No,
it so hard to
listen.
draw it.
I know what your hypothetical is, but that's
Well, then
it.
draw it.
It's not
Then
real.
draw it.
It's not
What's
real.
the danger?
It's not real.
If you had
It's
drawn
not
Bev,
real.
you could-
It's not real.
Who cares, Bev?
Me,
say
I
it was-
care.
Did I tell
It's
you
not
to draw it
real.
Because it's real. Bev,
There's
I
no
don't care. I didn't
supporting
tell you to draw it
geometry
because I wanted to-
behind
to
it.
force reality on you, Bev. I'm just trying to ask you to draw a hypothetical. What's so hard? I do not understand.
I don't know what. I don't know what's up with you, Funk. There's something.
block.
You've got something wrong with you.
No,
Bring-
I'm
just
just
bring your-
asking you
bring
to
your
draw
drawing
two
tomorrow.
theodolites.
Bring your drawings tomorrow,
and what's
we
gonna
can talk
change?
about it.
Bev could have drawn this drawing 10 times already.
Funk, you could have drawn it, right?
I would have gone to bed already if you did it, Bev.
You would have gone to
you're
bed. Are you not
sitting there
driving?
and
Are you not driving now, Funk? You would have gone to bed instead of doing your driving now, right now, would you?
Bev,
Just don't go to sleep while you're driving, Funk. Whatever you do.
I'm not driving.
Oh.
I'm already home.
Okay, so you
Oh,
could
cool.
draw your
You can draw
picture
it.
yourself then, right? Oh.
No.
Oh, right. Oh, so you've been lying then, Funk, right?
No, I'm saying I'm not inside at home.
Oh, right. Now you're walking round outside at home.
My family's asleep. I'm in my driveway basically.
Right. Okay, so we'll just draw your little picture on your phone now. Surely you must have some, like, your globe proof of how the surveyors work, or like how I imagine surveyors. Ask your mates. Some of them must have an idea.
You posted the drawing earlier. Bev, you posted the drawing earlier, which was exactly what I was explaining.
Okay, well, repost it then.
And...
Yeah, go and find it and repost it. And make any adjustments that you think you might need. And then we'll go from there.
I don't think it needs any adjustments.
Doesn't need any adjustments.
Must be one of Co-shows.
I just told you it was Bev who posted it. But, yeah.
You know, in your gang or whatever, Funk, you know, like, who do you hang about with? Who's in your crew? Are you with Fight the Flat Earth, or are you with from Gems? Or you maybe Speak Truth? Simon Dan, who's the top man that you hang about with? Who's your...
I'm mostly on the debate science and, like, you know, with Righteous Force.
Oh, right, okay.
Scalpel, DMAC, and Fug.
Okay.
And Sanic has been dropping out of there lately. He's not so much in there. Thank God about that.
Okay, so who's the best geometry dude within that crew, would you say?
Geometry dude?
Yeah.
Fug is quite good, actually, with
Okay.
a lot of things.
Sweet.
You know who Fug is?
Right, I'll go over there and find him if you think he's the best at geometry.
I don't think I'm the best to tell you.
Who's the best at geometry? Do you not have like a leaderboard? We do round here, don't we, DP?
Why do you think we have that?
Yeah, we have tests and all sorts. Regular.
You have a lot of weird ideas about us. I don't understand where you're getting that from.
No, it's okay. I mean, like, if you don't have the same sort of standards that we do, I mean, like,
what do you
I
think
don't
is
know.
going on? Do you think we have like meetings discussing how to get Bev next day? With nothing like that.
No, not me.
Nobody
No, I wasn't
cares.
thinking about me. I was just thinking, like, you know.
We just have meetings to test each other's knowledge, really.
Yeah.
don't we?
No, but
To
like,
push
really,
each other's
what-
boundaries.
Do
Yeah,
tests.
but what do you think? What do you think is going on?
Do you
when
not
Bev
do
is not
tests and all of that? Do you just
I
sit
do-
around having
I
a
do-
chat,
No,
talking about
when
what
we are
colour
on
underwear
Discord,
you're
we are
wearing
not-
and stuff like that, or what?
When we are on Discord, we don't do tests, obviously, because then we are on Discord speaking to each other.
Mhm.
But some people are doing some things. I have also done.
Some people are doing some things. Yeah, yeah. I mean, we've got
Yeah.
We do have.
believe
Most people do.
we have
Some things. Yeah, most
we have
days.
a couple of guys over there are pilots who have been taking some pictures from their airplane.
Of the ground?
Oh wow!
amateur.
Pictures from
I'm an
airplanes.
amateur.
Somebody went on holiday and
I'm
took
an-
pictures out the
I'm
window
a-
from
I'm
their
a-
airplanes as well.
I am. Bev, what's your problem, man? Come on. What's wrong with you? Jesus.
Really, dude?
It's
Bev. And
science.
for example,
Hang on.
me.
Picture
You
science.
started,
Bev,
I am.
I'm, for example, an amateur astronomer. So I have done a lot of. I have done.
There's no such thing as a professional astronomer.
What do you, what do you do? Do you look at the lights? I mean, have you ever done any star trails, Funk?
I have actually never done a star trail before.
Have you got a
I'm
telescope?
mostly following it.
Have you got a telescope?
Further. Yes.
And what do you
But my
what do you mainly
telescope
look
is
at?
I actually find it kind of interesting to look. Some of the planets are interesting.
Okay, have you done any photography?
Yes, I actually tried to do some things this winter. But the problem is that you need to have a really stable platform to do it, and yeah, I haven't been actually able to do it properly.
No, well, you've got a 1,000-mile-an-hour spinning ball, so that's not a very stable platform, is it?
Man, what do you think about them ones from the ISS?
It's an
What do you think about
equatorial,
them?
so it stabilizes.
What do you think about the ones, the star trails that Simon Dan was showing us from the ISS?
I have never seen star trails from Simon Dan. I've seen star trails
From the ISS?
from the, but nothing.
Have you seen star trails from the ISS?
Yeah, I've seen videos of that.
Yeah. What do you think about them?
It looks like star trails from the ISS.
Does
Okay,
it?
I'm gonna ask you a question, Funk.
Yes.
You're into this type of game. What kind of equipment do you have?
I'm not. Gang? What gang?
Game.
I didn't say gang. Game.
Oh, actually, I bought this
G-A-M-E.
telescope, but the telescope I own, I bought 15 years ago. So it's not part of flat Earth stuff at all, initially.
What?
But,
I didn't even say nothing about flat Earth.
15 years old. Does that put it out of flat Earth range? Too old for flat
Sorry.
Earth, that is it. Why is 15 years telescope got to do with...
No, I said I bought it 15 years ago.
Okay, so are you taking pictures, or you're looking through the eyepiece and you're telling somebody else what you see?
Yeah, mostly, yes. It's mostly for myself.
Right, for yourself.
Yeah, it's ours.
So there's nothing you can tell us or show us, actually. You can only tell us.
No, I haven't taken any. Yes, actually.
No, I asked you if you
did
just took
actually-
some pictures. You said yes.
Yes, I do actually remember. I took some very good pictures with my phone, actually, through the diopter of the telescope, of the moon.
Cool.
I can
You
see
got
if I
you got a
find
data
them,
just as well?
if you want.
With the moon.
Sorry.
Let's go. Let's
What
go.
did you
Let's
say?
see.
Yeah. You got data.
I have
behind-
to
behind
find
the moon?
them. I have to find them. I don't know where they are now. I probably kept it on a hard drive somewhere. It
In
was
your
on
house,
my
right?
previous phone. I'm not gonna look for it now.
Oh.
You're not gonna look for it.
Not
So
now, no.
You're not doing too well, are you, really? You've got pictures that you don't want to look for, drawings that you don't want to draw.
No. And
You're not
Bev
doing too
also
too
doesn't
well,
want to
Funk.
draw, so. Okay, I don't see how this change anything though.
Yeah.
No, it changes
Really?
a lot because it runs back into. I can tell you, I go through my phone, and I give you the data of what I see. I can give it to you.
Okay, what have you
Now-
done yourself?
I'll tell you like this: have I got Jupiter, anything like that? Nope. I don't have a telescope to get there. Not yet.
You don't have a telescope.
I got two.
Okay.
I have two telescopes in my garage right now.
Oh, okay, cool.
But
What kind of telescope
yeah,
do you
yeah.
have?
No, I
What
have them.
telescope do
Wait.
you have?
I have a sky. I
He has
believe
a what?
my
I missed that as well. I don't know.
100
Was that intentional?
Yeah, he has a scut.
Skywatcher.
Okay.
160 millimeter refractor. With I changed the person who owned it before me. Changed out the lens with an apochromatic lens, and the equatorial mount is called EQ. I believe it was 8, EQ8, something like that.
Is somebody's just sort of
wait.
give you all of that?
Wait. Can you show me that pretty picture on the day that you took that picture of your sexy lady telescope?
What? Sexy lady telescope.
The telescope that you have. Can you show me the picture of your telescope and give me the data when you took that picture?
You mean the picture of the moon, which I took?
No. I want to see a picture of your telescope and the day that you took the picture of that telescope.
You want me to take a picture of the telescope?
You've never taken a picture of that telescope?
Yes, I actually have.
All right, let me see it. I want to see that.
Can you not just take one
I
now?
don't dox myself. No,
wait, man.
I've taken picture of it from before, but I know that I'm maybe in those pictures. I'm gonna check.
And the picture that you post. Can I see the data when you took that picture?
What picture?
The date and the
I
time.
haven't posted any picture.
Oh my gosh. Where you from?
I'm from Norway.
No way. All right. Post a picture of your telescope. Cool. Boom. That's one.
Okay.
And then post the data. You can scroll up on the picture. It'll tell you the time and date. The time and the date when you took the picture.
Oh, you want the metadata on that picture?
Data. Same
That's
thing.
what it's called. It's like meta. It's like the data about the picture when it was took and all that.
What's the same?
I've just done mine. So Skywatcher, you say?
Metadata.
Skywatcher, you say, right?
So are we going to go?
That's the name of.
Wait.
The name on the telescope. Yeah.
Right.
It's the name on mine.
So are we going to go technical on terms? Because Bev can run you through that technical terms across everything. Right.
Sure.
So can I get the metadata when you took that picture, please?
Let me see if I find it in the first place.
I want the first picture, if you got it.
I've just took some pictures of ours, so.
Thank you, Bev. Sorry.
Yeah, no problem. It's a Skywatcher as well, right? So it's always a similar. I think Mark Taylor had one of these as well. The one Mark Taylor had, probably the same colour. And like you see that bit that in that bottom one, the one that just says above the telescope, right? I mean that's where Mark Taylor said he'd fixed his camera to it, right? Because in order to take photography and do the photography for it, right? That's where you have to fix your camera. You have to get a proper mount for it.
I didn't find it. It's probably I have it probably on the archive on my hard drive.
Okay, can you not just take a quick snap of it now, or?
No, it's packed down in cardboard in the.
That's what mostly happens with telescopes, right? People get them, they look at the moon like maybe once or twice and go, "God, that was shit," and then they pack it away in cardboard or something and leave it at the side.
I can tell you what happened, Bev. what happened was that I got a baby 2 years ago, so I haven't actually had the time to use that so much. Plus, I've been working a lot, so.
It's okay.
But before that, I used it a lot more.
Very noble.
Wait.
Don't look at the stars.
Wait. You've been working a lot, and everybody else has not been working that much. I need your job.
What? Do you don't have a job, Redman?
I got a job. I like to work.
You want...
Come on now.
What are you saying? You said you wanted to work more?
Yeah, go back up to the hours I was at.
What?
I'm only working half right now.
Oh, okay.
Yeah.
Due
I want
to
to go back up to the hours I
Corona?
want. Yeah, but you know, even with that, the bigger picture of it is, I got telescope. I got 1, 2, and these things are looking at well.
What kind of
They ain't looked
telescope
at
do
the
you
sky
have?
in a while.
What kind of telescope do you have?
To even remotely take a picture of anything that I want to look at,
Okay.
I can't get the picture. So if my telescopes at the house can't get the picture, I'm trying to see what you have so I can get a picture.
Okay. Actually, the way I took the first picture before I bought a Nikon adapter to the telescope, I actually
Nikon
used
what?
just my adapter.
Yeah, Nikon adapter. What camera?
D90. I have a D90.
D9 and 93. Okay. Yeah.
90. D90. D90.
90. Cool.
Yes. And before that, I just used my phone and took picture, and it was actually quite good pictures. I was thinking like it might not be able to focus or something, but it was perfectly fine. To clear pictures.
But you know, do you know the difference between a phone and a camera?
Yes.
No.
But
Do you really
the
know?
camera has a phone though, so the camera doesn't have a phone, but the phone has a camera. That's the difference.
No. What's the difference between a DSL versus a cell phone, camera-wise? Do you know the difference?
Sorry, what you're saying? DSL?
I said the lens. Do you know the difference between the two?
Yeah, some of it.
Okay, well, just tell me.
A D90 is I don't know what the English word for it is. It's a mirror-based camera. Mirror reflex camera, it's probably called.
Okay.
Yeah.
So I'm gonna break it down for you right here. You know, because when you have a cell phone camera, it's still not a camera. Versus
why would you say
DSL.
that?
It depends on the lens itself. Do you understand that? I watched a couple of videos. What's the difference between a cell phone camera and a DSL, a physical camera with the lens on it? It's all on the cell phone. It's digital, still not a camera. Like what we've been told. I give you that.
What is the difference in your idea?
In my ideal, it's not my ideal.
No, sorry, not your ideal, but what's the difference between the DSL and the regular camera? What you call is a regular camera?
The cell phone is not a camera. It doesn't have a lens.
It does have a tiny lens in the front, though.
Tiny lens.
Tiny lens.
Did you construct it to understand what I'm saying? As you can strap on any lens on the DSL to see in the sky. We'll just go there. In the sky, what you're gonna see? Boom, boom, boom.
Oh, you mean it's not an exchangeable lens? Is what you're meaning?
No. Do a little bit of research on, far as how the cell phone works, camera, and the DSL for yourself. You'll start realizing that when you, now I'm just giving you this, when you look at the moon and you take a picture with your cell phone and it's all the way zoomed wide, you take that picture in your eye, the moon is going to be bigger than what that camera took there. When you zoom in, you still get more detail from your eye versus what your cell phone takes. These are small things that everybody needs to sit back, not bias a flat earth, round earth, concave, or anything like that. Sit back to yourself and one moment to yourself, you're sitting at your back porch and you take a picture, boom. And you look at your cell phone, oh, I gotta blow that up. Cause that's not what I see what's going on there.
Well, I did Google what you meant, and it has a different term. Didn't actually understand what you mean. The camera I have is a I think it's called DLR or DSR. I'm not sure. Digital with the reflective mirror on it. Right. DSLR is the one that doesn't have a mirror.
What? Didn't you say it did have a mirror though? Your one, anyway.
Yes, that's correct. Mine is a mirror camera.
That the D90 is a mirror.
The D90, yes, has a mirror on it. Yeah.
Okay, so that's the DSLR.
That is DSR, I believe. That's DSR. DSLR is the one that most modern cameras does not have a lens in it. No, mirror in it.
Do you know what you can do with that camera?
Well, DSL is digital single lens, isn't it?
Right.
So yeah, like they do have a lens, but I mean that's as far as I understood, the DSLR, right, is a camera body that you have interchangeable lenses for, right? Isn't that what you do when you put it on the telescope? You take the lens off, right, and then just affix the camera to the telescope, and the telescope becomes the lens. Isn't that what happens?
Yes.
Is that a yes?
Sorry. I think you're right, actually.
You think I'm right? You're the one that's done it, haven't you? Aren't you?
No, I said this term was new for me. I haven't heard that term.
You said you'd done photography through a telescope.
Yes, I have.
With your camera.
Yeah.
You seem very vague about what you're talking about here again.
No, you can...
I'm not so sure whether you actually...
lens on my D90.
What?
You can remove the lens.
Yeah, you have to, don't you?
What is that camera called? I don't know.
What is what camera called? The D90 is your camera. What, yeah. You don't know what it's called, or what?
No, I don't know what it's called, actually. I'm asking
you said it's the Nikon D90.
Yes. But you have this term DSLR and DSR.
No, DSLR. Right?
Yeah, and what's the other one? That's also.
I don't know. Is that what yours is? No, I mean, what do you imagine yours is? I'll tell you, yours is a DSLR.
Is my camera that?
You can get a mirrorless camera with a
Yeah.
It
I
has
know.
interchangeable lenses as
Oh,
well.
have you been called in to help
Yeah.
here?
All right.
Whatever.
Oh, I just am
Oh my
listening
God,
in.
Bev! Come on, man.
Oh, do you want to
I
help
have
him out
a
on how he's
Okay,
doing
hold
his
on.
Out here
astrophotography?
to, you're making everything like somebody has to get somebody all the time.
No,
Bev.
I'm not. We're just
No,
trying to
you have
establish
have a
whether
normal
you
discussion here.
actually know what you're talking about, or whether you're just sort of making stuff up, thinking that you can
Well, I'm not.
sprout some fancy
Didn't I
numbers
say-
about cameras and stuff.
Didn't I say I'm an amateur astronomer?
You
and
did,
I have
yeah.
a Nikon D90.
Yeah, well,
It's a
that's
mirror-
not really an
it's a
amateur
mirror-
piece of
it's a
camera,
mirror-
though. That's a pretty professional piece of kit, right?
Yeah, it costed me $700 and I bought
All right, you got it cheap then.
and it's not for
Wait,
sale
wait, wait.
anymore.
When did you buy that?
I bought it that's quite a few years back. I think I bought it like 8 or 9 years back, 8 years back.
That's cool. That's cool. Those
sell,
cameras right there.
They don't sell it anymore. I know.
Of course they don't. No. Of course they don't. But the camera that you have, if you can get to the countryside, go out and land where you don't have no noise pollution, no light pollution, any of that. When I say noise pollution, is light pollution. You can go out there yourself.
Yeah.
And do some real astro pictures of the sky for yourself.
I have
Can you show me?
actually, when I used
Can you
it,
show me?
I actually took it, took my telescope with me. No, I didn't took pictures back then when I did it, but I brought my telescope with me because I bought I got a tip from the previous guy who owned the telescope, and he said you should use a starter battery, like with sort of it's easier to carry with you because it uses a 12 voltage battery on it.
I'm talking
You need
about
to have
what
some
did you
power
take
source.
in? What did you take in the sky? Do you have anything like that? You, not anybody else. You.
I'm talking about photographs.
Photographs or even time lapse, because you can time lapse with that camera. I checked on it myself.
Yeah, it's no problem doing time lapse, but I haven't done that.
You had this camera 8 years and you ain't did no time lapse.
Yeah, that's true. I bought this adapter. I bought it last year. The Nikon adapter. Before that, I just looked through it with my own eyes.
Yeah. But can you bring some proof of what you shot and the metadata?
What are you talking about? I just told you now that I haven't taken any pictures with it, or the pictures I took actually this winter was not very good. So I'm not sure what's wrong, but I called
It's
the
wrong.
place.
Not a wrong. I'm not saying a wrong. What I'm
Okay.
saying is, give me what you took, and let me see your metadata.
You want to see the pictures which I took?
Pictures,
I don't know where they are.
metadata.
It might not be anywhere. It might be deleted. I don't know.
Huh?
It's on a mini SD, then the SD camera on the camera somewhere.
So you had this camera freaking 8 years. You taking pictures.
Yeah.
I mean, just listen.
I didn't buy the
have
camera to use on the telescope though. So.
Yeah. You got family and friends and everything.
Yeah.
Because I'm gonna do the same thing with my camera. Cool.
Yeah.
But the data that might be sufficient. You shot the moon. it tells you on the camera.
I didn't take that with the camera. I took it with my phone. I said.
No, I don't care. I don't care nothing about the phone. I care about the freaking D90. That's all I care
Yes,
about.
but Redman, I told you I did not take the pictures of the moon with the camera. I took it with my phone through the
Okay, so
telescope. You
cool.
understand?
So
So
I got you.
don't
So you
don't
never
ask
take
me show me a
no,
picture of the moon with your D90 because I didn't do that. Right?
you never done it.
Yes, I told you. Now I told you. I can tell you again. I have not with my D90. I took it with my
Cool,
phone. That was just for
cool.
fun.
What have you taken with your D90?
I've taken pictures of nature on trips on vacation, stuff like
Yeah.
that.
Okay.
But
Down
but I
here,
mostly but I don't use it's quite heavy camera, so I don't bring it with me when I'm going
I
like
don't.
on
What is heavy?
short.
2 pound, three
I
pound,
mean
5 pound. What's heavy?
it's quite clunky, you know. I have a bag with it.
Yeah.
And it's rather relatively heavy compared to the other camera which I have. I
Right,
have
right,
like a
right,
compact
right.
camera which is weighs nothing. Also, like I'm a little bit afraid it might get stolen or something, you know, if I'm on vacation. It's quite expensive camera, so
Well, it was at that time.
yeah.
At that time.
I know, but like it still looks expensive, and I looked up. You could still buy it used for actually quite a bit still.
Mm,
But yeah, I agree. I don't know.
yeah, I mean that's. I'm telling you, go a different direction. Put a what is it 35 millimeter and take a picture of the sky in time lapse. It costs you
Okay.
$18. It costs you $18 to get the I can't remember the name of the time lapse stuff. That way interferometer. You can put on your camera and it takes a picture for you. 2 hours, 3 hours, you good.
Oh yeah.
You take
I think
yeah,
it's
yeah,
built
yeah.
in, and you can also
Give me that.
connect a computer to the camera to make it a computer control the camera. So you can
Yeah.
choose the exposure time and all that yourself through
All
the
right.
computer.
Yeah.
I
So
haven't
why are
tried
you
it,
so
but I read it.
yeah, yeah. Well, but why are you so behind the time?
I don't know. Guess I'm lazy. I am busy with my life. What can I say? It's not my main job. It's just a hobby,
See that,
and
mate?
I have uh um. It's like it takes a little bit time to set up the telescope and all that. So I don't know. It's
You
like a
have to
bit.
understand.
It's
See,
a little bit of a
I'm
threshold to do it, you know.
yeah, yeah. I'm gonna give you real talk right there. Just listen for what it is. A man will be determined to prove something for himself, to know that what he's doing, he believes in.
True word, man.
I will leave you with that. But
Yeah.
when I get my camera and I do the things that I let my camera do in my backyard, I like somebody to do it at the same time so I can see their skies because I can only see so far. Number
Yeah.
one, if you have the camera, you don't need a telescope to just to see the sky. You don't.
Not to see the sky though, but if you want to see something much more detailed, I mean, the telescope lens is like it's like 10 times bigger than the lens I have on the camera itself. So
Yeah,
yeah.
yeah, cool. Cool.
Plus,
Can
it's
you
on like
next
equatorial
time?
mounting zone.
Next time you come here, can we see some of your photos in the metadata?
I can
When you take it.
I can promise you that if I next time I take pictures with it, I might come
No,
back here before I take pictures with it because I'm not gonna promise something I cannot hold.
I'm not asking for a promise. I want to see
Yeah.
your first pictures in the beginning and the
Yeah,
metadata.
sure. I can, of course. This is flat Earth stuff, so of course you guys want to see pictures of the sky and stuff. I'm gonna, if I take, when I
Dude,
take
what are you
pictures, I'm not
talking
gonna say if.
about?
I'm gonna say when I'm taking
We
pictures, I'm gonna
look.
put
Did
it.
you just say we're flat earthers, and of course we want to see pictures of the sky? Because
No,
you're not talking
maybe it's come
about
out
me.
wrong. I meant like.
No. I'm level. I'm level across the board. Level what I stand on, what I see.
Okay, level Earth. Okay.
Thank you.
Well. Yeah. I don't mind posting these images, of course, but I know that I have some pictures of the telescope somewhere, but I know that I took it with like family members around, so there might be some doxing. So I'm not sure. You can see.
No.
Doxing.
Otherwise, I have to.
No,
otherwise, I would
dude,
have to.
pictures aren't doxing, are they?
I don't want my face or anything.
Okay, I mean that's fine, but that's not doxing. You just don't want your pictures of your family on the internet. I mean that's fine.
Or like basically so nobody can find out who I am. Basically, that's why.
I don't care. I don't care nothing about that. I care about.
I know you don't care, but like
you
who
shot.
knows?
What shot in the sky? If you got in the picture a selfie. No, wait. If you got a selfie into Jupiter or Mars, then I might care a little bit about that. You ain't got to share it. I don't care nothing about that.
What do you mean by
You don't know what a selfie is?
Yes, I know that it's a picture with my face on it, but how can I take a picture of Mars and a selfie at the same time?
Just same way as you're trying to say, I don't want to be doxxed, but you're next to Mars.
What the fuck are you talking about with that?
I know. I'm keeping it real. That's how it sounds to me. I can laugh at what you just said.
Now. You're not
no,
making sense now. Okay, tell me exactly how you want that picture to be taken. Tell me now.
I'm gonna tell you right here, right now.
Do that.
Give me your picture of what you took of Mars. I didn't say.
Okay.
I didn't say family members in front of the picture or anything like that.
No.
And give me the metadata, and we're good.
Metadata. Okay. Why would it matter? Tell me one thing, Redman. Why would the metadata matter to you? Why would the metadata matter to you?
I would give you my metadata, anything I took.
Yeah,
I wouldn't be scared.
Whatever. Let's say the metadata said, "Oh, a picture was taken 3 years ago." So what? Like, how am I supposed to interpret anything from that? Is it to like prove if you're lying or not, or something like that?
There again, for one man to say, "I took this picture," and listen to it. I took this picture. No, you didn't take this picture. Nope. Right here. Here's the date I took the picture. There you go. You got it.
Okay.
You take from it whatever you want.
Sure.
Real time.
But if I take picture with my telescope of Mars, it's gonna be hard for you guys to know if that picture is actually me who took it or not, because there's a lot of pictures of Mars out there.
Yep. Exactly.
I'm gonna give you an even deeper thought. Psychology. So if I take a picture, you be like, I don't think you took that picture, and I come right off the cuff. Here's the data. That's what I took it from. From there, boom, boom, boom. If I come right off the cuff and tell you, right there, I give it to you, are you still gonna call me a liar?
Why would I call
It's
you a
like
liar
really,
in the
really
first
hard
place?
to take a picture of Mars, like to actually see any detail.
Yeah, it's very blurry. Yeah, I'm right. You're right.
First of all, you have
So
to wait
how,
for Mars opposition, which is every 2 years. And people that know what they're doing will do like a video and stack the images to actually get a decent picture that you can see.
right.
But if you just want a dot in the sky, you can just do that with any camera, even the cell phone.
Yeah.
Has anyone ever told you you sound like Bob the Science Guy?
No.
I don't think it sounds so much like that.
You
Actually.
guys are literally the only ones that have ever heard me, so. Sorry for jumping in like that. It's just, I
No, you good.
tried
You good.
many times to take pictures of Mars and they always just come out overexposed.
No, I got pictures of Mars on my cell phone.
Yeah, it's
Right
just a
now.
little dot. Yeah, it's just like any other star, a bright star.
Yeah.
It's a blip,
Yeah, just a light
blip
in the sky.
A
I
blip
could
in the sky.
actually determine when I looked at it with my telescope. Yeah. But I think probably the most exciting planet to look at is obviously Saturn, due to the ring outside it. It's
It
very
is.
easy to see.
Oh wait. So is Saturn farther than Mars?
Yeah. But it's much bigger. Plus, it's
Okay.
I would say it's the ring which is most exciting to watch.
You know, I'm in your fantasy right now. So just look at it
Okay.
for what it is. You said it's
Yes.
bigger. Who said it's bigger than Mars?
Angular size, it's bigger. I believe it's a little bit
Angular
bigger.
size.
Not a lot, but a little bit bigger. It's also determining on where it is in the sky, but yeah.
Yeah. So what is the focal length of your telescope?
I believe it's oh, I have to think. I think it's f8 or something like that.
No, like millimeter. You got millimeter on that?
Oh, okay.
Yeah. Help me out. Sorry,
It's
bro.
160 millimeter in diameter, but I would have to think about if it's f8, then I can just do the math on how long it is.
No, you said 160 millimeter.
Yeah.
Wait, he's gonna make me jump up there and get on the shelf and get my telescope down. But I think mine's more than yours. I want to see your pictures. Bad light.
Game
Because
on.
I think mine might be more than yours. Wait. So I need you to really confirm that. Because where's my step stool at? What you really thinking? What that size is? Because I can take a picture of this. Cause my I ain't gonna say degree, but I can see what my telescope is right now. What you got? Cause I move all this.
What kind of telescope do you have?
No. What's your millimeters on your telescope? It's a mirror telescope. The light comes in.
Yeah.
Bounces off the mirror, and goes back up.
Oh. No, that's you have a Newton bucket basically. I have a refractor. It's a different kind of telescope.
Who said it's scientific?
I didn't say
Do you know the
scientific.
difference?
No, I know what kind of telescope you have based on what you said there.
Okay, well, post a picture. You've been sitting in your driveway.
Google
No.
Skywatcher.
I'm not gonna
160
Google.
millimeter.
I'm not gonna Google. You post what you think I got. I told you what I got. So you post what you think I got. You're all about this life of looking up in the sky. You know what I got, post it. Simple. I'm going up to the rafters. Got me working hard in here. You know, it is what it is. Lovers don't look at stuff. I go in and go get the shit. My best telescope. It's still trash. I'd like to see what you got. For sure. I got some damn cobwebs on this. It is what it is.
I posted some telescope types. You have a Newtonian telescope. I have a refractor.
Okay, let me see what you got. Where you posted that?
I posted the type of telescope. I don't know exactly how yours look like, but you have a Newtonian telescope. And that's not the same type that I have.
What did you post it at?
I posted it in debate, I think.
I can look at what you got. Well, what you saying? What you saying?
Just open up the link and you see some telescope.
Okay, which one of these? I tell you what, screenshot what you think.
You have the Newtonian one, and the one on the left side I have.
So, which one? Screenshot. You can crop it out once you hit screenshot, and you can crop it out. This is mine. This is yours. Just do that. Oh, they're funny right there. Show you what this.
Or have we got stalled here on something? We got a telescope measuring contest going on.
Telescope war.
Yeah. It's funky. Are you going to come with anything, or are you just going to sort of get pictures of other people's telescopes off the internet and say, are you waiting to see Redmond's first and then you can decide what you're going to show? You're gonna pull out. Oh, he's gone.
He already said he knows what I have. I tell you, man, this guy is a mind reader. Whew.
I just posted what I had earlier.
I need to know when I can go purchase my my lottery ticket so I can hit $1 million. I'd be good. House off. Come and see Beth. I'm vlogging in VP. He's coming in. Freaking Scorpion. Y'all are all coming in. We're gonna have a good time. Oh shit! I gotta get turned up. Sorry.
Bring turn
One
up
left
with you.
out. One left out.
Right,
Yeah.
I'm
I gotta bring him with me.
I'm gonna have to get off, guys. It's 2 o'clock in the morning.